Yeah, thanks for inviting me out here. I want to mention right at the start that I am recording this. So if you see something, don't feel like you have to write it down, right away. I'll make sure they send out the recording so you can review it later on. So I'm actually really glad that a lot of you are pretty new to Jump because I think seeing a data preparation workshop right at the start of your Jump journey is a really good time for it. I know I started with Jump in a kind of a funny way. So I started in Jump version 6, I think it was, as a grad student. And I was switching over from R and SPSS. I don't know if anyone's an SPSS user. But I had this weird experience where I could use Jump for my analysis, but I didn't know a lot of its data preparation tools. So I found myself always going back to Excel, going back to R, going back to SPSS to do data preparation, and then going to Jump to do the graphing and to do the analysis. And I finally had to tell myself I need to try to learn to do this in Jump because I know I could be more effective. But I don't know if any of you have this experience. It's hard when you don't know the way a new software does something and you do know how to do it in another piece of software. It's tempting to go back and just use Excel, to use whatever else you're using. And so I kind of want to challenge you to give yourself the opportunity to learn how to do these things in Jump, to struggle a little bit, because struggling in new software is common, because I promise you it'll pay off. Jump is hands down the best software for preparing and cleaning data. There's really nothing else that compares. You just have to know a little bit about how to do it, and you'll be so much more effective. So it's okay to struggle a bit at the first time doing this in software. So just to give you a sense of what I want to talk about today, the first part is really all going to be about importing data and table setup. That may sound a little bland, but it really isn't. Jump does some really neat things that make sure that you get your data set up quickly and effectively, and you can automate it in a way that if you have the same data coming at you repeatedly, you can just script it and do it automatically. So we'll talk about importing in Jump, so some of the import wizards, copy and paste some remote sources, things like queries and REST APIs. We're going to talk about working with column names, which turns out to be kind of a struggle sometimes. We'll talk about metadata, and I'll unpack what that really refers to. And then we'll look at data filtering, so things like row filters and row subsets and data subsets. We're going to move on to restructuring, so stacking and splitting. So when we reorient the cells in our table to be in a long format versus a wide format, each of which is sometimes useful. So knowing how to move back and forth between them becomes very useful. We'll look at merging data, concatenating, joining, updating, and using something called the query builder, so bringing data from multiple sources together. And then we'll look at aggregating, so tabulation, like pivot tables in Excel, and summary, so taking summaries or aggregations over particular rows in our table and doing it now in new columns. So that's the first part of the day. We'll take a break, and then we'll look at data quality in the second part, first using formulas, deriving variables, looking what we do when we have wrong values, so things like recoding, and even using find and replace. We'll look at extreme values, so looking for outliers, using a couple specialty tools in Jump, and how we can use Jump to find missing values, to look at the pattern of missing data, and to look at ways that we can work with those missing values. All right, how does that sound? Sound like it might be useful? Hopefully. All right, so let's start into it. So first I'm going to start with table setup. Now Jump has a lot of tools that can bring in data from lots of different sources. And in Jump 15, which is just released, we added a few new ones. I'll make sure to point out times where I'm showing something that's in Jump 15 only. Most of everything I'm showing is in all the versions of Jump back to version 10, actually. But there are some new things in Jump 15 that help you bring in data from new sources. So I'm going to show some basic ones first, but just to point those out, does anyone have data that is in a PDF file? So for some weird reason, somebody gives you a PDF of data, right? I'll show some examples there. Jump 15 has a PDF import wizard. It'll pull data out of the PDF. Does anyone work with XML data or JSON files? Maybe not. I'll show this very briefly. It's a format you'll encounter a lot when you're working with web sources, XML, and JSON as well. So there's a WIT importer there. But let's first look at just the Excel import wizard and the text import wizard rather quickly. So when you open data in Jump, just using file open, when you point it to an Excel file or a CSV file or any kind of text file, the default is to give you an import wizard. So I'll just select an import file. This is just sample data that comes with Jump. And I'm going to point it to something called restaurant tips. And the first thing you get is this Excel import wizard, which gives you a preview of the data you're bringing in. In Jump 15, you also have the ability to pop out a little histogram to kind of explore what the data look like before you even get it into Jump. But the preview gives you a sense of how Jump has determined where the columns and rows are. And for most well-formed Excel files, you don't have to do anything else. You can just click import, and the data come into Jump just fine. Now the reason that worked is if I look at the Excel file that I pointed to, that Excel file was actually pretty well designed. It didn't have rows at the top of the table that were pushing the first column down or pushing the first column headers down. It didn't have anything to the left. It was just a kind of a perfectly formatted table. Most of us who have data in Excel, it doesn't look like that, right? You'd have different. Let me just close this real quick. Oh, it is closed. Now it's more closed. Most of our files don't look like that if they're coming from Excel. What they might look like, and I'll just give you one example, is a situation where you have multiple sheets with data. So this is 2009, 10, 11, and 12. You might have what are called cascading headers. So winter applies to several of the months here. Spring applies to several more. And you might have cells that people have merged. So a cell that spans multiple rows. And you might have that over several different years, plus some stray data at the bottom that just describes something about the table. That seems a little more typical for what I've seen. So let's see how the Excel import wizard manages that. Again, I'll do File Open. I'll point it to that folder. It was just called Texas Precipitation. And it guessed pretty well, but you'll notice that it did something interesting here. It says winter, winter 2, winter 3, spring. So it found that first row that said winter and said, okay, I guess that's probably the column header. And Jump doesn't let you have the same column name for multiple columns. It's a structured data environment. So it has to append some kind of number at the end. So we have to configure this to do something different. And this is where the worksheet settings here become useful. We have an option for where the column headers start and the number of rows that contain column headers. So right now it's set to 1, but watch what happens to the headers when I click up to 2. It now figures out that, okay, winter to be concatenated with the row below it, January, February, March, etc. So it does a very good job figuring that out. Texas was just fine. It spanned those rows without me having to do anything. And finally, there's one little bit here. Remember that stranded row? I'll actually just select row 4, the last row where there are data, and I can actually later on designate that as the last place where there's data. I'm going to do one option here, which is called concatenating the worksheets together. Because remember, I have 4 worksheets that have the same data, and I'm going to tell Jump to concatenate, to squish them together into the same table. So all those blanks there are because I didn't tell Jump where the data ended. So let's do that right now. I'll say the data ends on row 4 of each of these. And suddenly now it's pulled all those sheets together, and I can actually just click import here, and I have the data. Now you may notice something here. I have nothing that identifies which sheet the data come from. And this is really important. If you're going to concatenate and you don't have an identifier in the table, you'll want to make sure Jump adds that. So let's go back, and Jump will remember everything we just did. I'll go back to Texas Precipitation. Click Open. And there's the option, Create a Column when concatenating. And Jump now adds the source table. So that pulls it from the sheet name of the Excel spreadsheet. All right, and so that's more or less our final table. Now imagine these are data you bring in on a routine basis. Every table you open, and Jump will have a source script. I'm going to click on that and click Edit. And even if you don't know JSL, Jump has written the actual code for you for opening this table. It uses an open function, and then it has a number of arguments that describe how to open the table and where to open the table from. So if you had to reopen these data, from a new file, you can just click that play button and it'll actually run the exact same thing again for you. So if you ever need to update with a new file, you can do that. I highly recommend, if you're redoing analyses over and over, to learn a little bit of JSL. It's actually a very friendly language, and there are things that you can do to make it really simple. Like, imagine if this file moves around on your computer. It would be one line of code you have to change. You would say pick file. And now when you run this, Jump will actually prompt you for where to pick that file. So I can say, Texas precipitation, and it'll open it. So a little bit of JSL goes a long way in Jump, and I'll point out places where Jump writes the code for you again. All right, any questions on the Excel import wizard before I move on?
Sorry, could you repeat how you select the end of the data?
Exactly, yeah. So let me open it from fresh again. So when I selected the file and clicked next, right down here, data ends with row. You enter it in there. And so if I have nothing there, it'll give you the whole list. Now a trick is you can actually just select in the list or select in the preview the place where the data ends and click that plus sign. And so that will enter in the row for you, which is a nice way. Yes?
Can I send from the beginning, from the end of the table, number of rows?
Oh, so do it.
Like in the CSV wizard, you can go from back. So I have different
I see what you're saying.
lines or different amounts of lines. I just want to cut the length of the last 3 lines. Or 5 lines or 6 lines.
That doesn't seem to be an option. I've never seen that with an Excel file. But you're right, with the CSV, you do have the option of reading in that kind of subset. Yeah, I haven't seen that with the Excel import. I'll put that in as a request, though. That's an interesting use. Okay, so let me show you what this looks like when we do it with a text file, because it's going to look very similar. If we put a text file here, I'll choose restaurant tips now as a text. Or maybe I don't have it when it's text. I'll just choose big class. So a text file here. Data using preview is the default. Since it's a CSV, it pulls up sort of a basic view. And we have the choice here whether our data is separated by tabs, commas, spaces. It also gives us the option, as you just saw in the question, of sampling, so pulling a subset in from a very large CSV, so lines from the start or lines from the end. Or we can bring in everything. We can designate whether our file has column names. Some CSVs do, and some CSVs don't. And other compatibility questions. I'll just click import, and you see Jump brings it in and titles our columns just as default incrementing column names. So text import is pretty straightforward, and that'll work on pretty much any file that has a delimiter that you can use. So that can be anything from a special character you design, or it could be tabs, spaces, quotes, anything like that. All right, let me show you PDF import, because this comes up a lot. We see when we're working with sometimes sensors or machines that won't write out a file for you, but will write out a PDF. And I want to give you a real example. I was working in my new office in a new building. We moved recently back in January, and it was getting way too warm. And facilities wouldn't believe me that it was getting warmer than it should, so I bought a sensor. I bought a little USB sensor stick, and I started collecting data for 3 or 4 weeks. And I wanted to send them some graphs of the data, and I want to show you what the only thing this little sensor would print out for me is a PDF, which was really frustrating. I called the company and I asked, is there a way I can work with it as a CSV? And they said, nope, our software only gives out a PDF. Why the PDF used yellow for the temperature? Oh, it comes up green there, that's good. On my screen it's this bright yellow. It's basically the worst. And so I could copy this out, but notice what happens when I select. It's going to select very awkwardly, and I can tell you this doesn't paste very well. So if you ever had this issue, Jump has an answer for you. If I go File Open, I'll just point it at that PDF. It's going to bring up a wizard here that searches for tables. Now, I can change this. I can say where I want the table to be. Right? I can expand. I can grab the table edge here and only pick that table. Or I can pick the second table here as well. And so jump does a very good job detecting the tables, but if you want to modify them, you can. And it's actually going to go through the whole job of concatenating for me. So it actually found those tables, and because, and I'll show you the controls up here, concatenate tables with matching column names. If you draw tables and they have the same name, no matter where you draw them, it'll try to concatenate them together, to put them row-wise together. And so when I hit OK, jump will actually bring in the temperatures here. Now there was one stray character there. There's the Fahrenheit, so I could delete that out, and I can make, I'll talk about this in a second, set this column back to being numeric. And now I actually have a temperature column. Time as well, I could come in here and make this look a little better. We'll talk about formatting. But I just want to prove to you that my office was getting too warm. So if I graph here and put temperature, and let me actually just do, for time, I'll do time of day. So we can put that. It was getting into like, there was one day it was up at 86. It's too hot. And there's one, it was now 76 degrees. And I should have converted this to Celsius for you, but it's too warm. I want my office cooler. Anyway, facilities laughed at me, and they fixed my thermostat. So data will actually solve problems. So PDF import does a very good job. If you give it a very large file, it does just fine. I'll show you what it does with 2 pages. Since it has the same table on both pages, it'll replicate what it found and also just import those for you. And so it does a very good job. Now I want you to see, again, the source script. Every file you open in JMP will have that source. So if you go to Edit, you'll see the code for this. And the way this code works is pretty straightforward. It points the location to a file, and then it says in pixels where the tables are. So if you have tables that are produced in PDF form and they're always in the same location, you can just have JMP point to those and open them all together. Any questions on PDF import? Yeah?
I have 2 things. So one, if it's a mixture of text and data, and the second one, if it's not a PDF that's produced by machine, but rather scanned in PDF.
Yeah, really good questions. Text and tables, it's just fine. JMP's actually very good at figuring out what part of the data is actually text and what part is the actual table. Let me see if I can show you a more awkward one. Actually, these are all pretty good. So it usually will ignore graphics, it'll ignore all the things that it doesn't think are tables. Your second question is a really good one. So what if it's a scanned PDF? The way JMP is working, it's looking at the text as part of the table. So a scanned PDF, until you OCR it, run it through OCR software, won't work. JMP does have the ability to connect to R. And so what we've seen some customers do is their workflow is they have JMP point to the file, they call R in the background to use the OCR, optical character recognition, save the PDF, and then pass that back to JMP. So they do have a workflow for it, but we didn't build OCR into JMP. Yeah, great question. Okay, so let me show you one more, XML and JSON imports. So these look pretty similar. These file types are common when you download data from the internet. Does anyone use a Garmin watch or a Strava or have running data? A few nods. So Strava data or Garmin data, when you download it, come out as a file called a TCX file. TCX files are just XML files. They look like this. So XML looks a lot like HTML. It's a tag-based format. So you have a tag that designs sometimes columns, sometimes rows, and the data are all embedded in there in this sort of hierarchy. So they're historically very, very annoying to open. And what JMP did was build an import wizard that can make guesses at the structure of the data. So just like before, I'll point JMP to the file. I'll use data using preview. And at the start, JMP doesn't give you a preview yet. I mean, it shows you what you have, but it doesn't make any choices for you yet. If you're really knowledgeable of the file type, you can go through and designate which rows or which sections and tags design the columns and the rows. I'll be honest, I find that I'm not very good at that. Instead, I just like JMP guess for me. So there's a guess option here. It's almost like the magic button. And I could say, pick a tall. And that's actually what it is. It's almost always tall or wide. Very rarely do I see huge as an option. That means that they wrote the table to be both really tall and really wide. Tall is pretty common. And I know it is for me because these are 5-second increments where my watch is picking up on a run I did. And so if I hit OK, I now get this 265 row table. And it has things like distance and speed, heart rate, that kind of thing. So very simple XML import. The source here is going to look a little bit more complicated because there is a lot of things that has to decide for you. But again, as simple as just hitting run if you want to run it again. All right, so that looks the same for XML and JSON files. Okay. So let me show you copy and paste because this may be a way that a lot of you bring data in, and I want to show you some tricks in JMP which if you've used copy and paste, maybe you ran into that were kind of frustrating. Let me actually pull open a simpler Excel file here. We'll just make it straightforward. So if you're going to copy from Excel or any other software, I just want to caution you first to be aware that the way Excel will copy cells is based on the formatted width. So if I have these cells formatted to show no decimal places, so if I format those and say, show me 0 decimal places, if I copy, the only thing your clipboard has a knowledge of is the formatted cell. So just be aware, copying is not a great thing to do because you copy out a rounded version of a number. So with that said, let's see how you would copy, let's say, the first 10 rows into JMP. So let me copy them. I'm going to make a new data table, file new. Now, because I've copied the column headers, the thing I want to do is paste with column names. So paste, but treat the first row as a column name. And JMP does just fine, right? It actually puts the column names at the top, and you'll see on the left-hand side, it's guessed correctly at the modeling type. And we'll come back to the metadata there in a second. Now compare that to a table where I just paste. And you get, I don't know if anyone has done this when they first started using JMP, you get this annoying situation where your columns are labeled 1 through 7, but your first row is the column names. And if you look at the data types and modeling types, it's gotten them wrong. It's treating them all as character columns. Now there's a quick fix, and I'll show you this again. If I take that first row, copy it, select the columns and paste, I can move those columns over. But it's still not very good. I have to fix a lot of other things. So make sure if you copy with column names, you also paste with column names. All right, how about this? This is something that I feel a lot of people have trouble with. What if we wanted to add in the next 10 rows of data? So I copy those. I go to the table and I try to paste, and nothing happens. Has anyone tried that before and ran into that? So there's a very specific way JMP works with data selections. And I want to point out 2 things first, and then I want to show you how to paste the data in. The first is when you select columns, of course your columns are selected everywhere. When you select rows, your rows are selected, and you could select some columns and some rows. Hopefully everybody has discovered that these 2 sections here are the deselect operators. You can deselect the columns by clicking in the top and deselect the rows by clicking in the bottom. You can also shift-click to select all and shift-click to select the columns. All right, so those are really useful. If you want to paste the data in, the trick is you click in one empty cell, and then you click paste. And the reason that works is because I have the same number of columns in this table, and they're the same type of data as the columns I'm pasting in. If I click somewhere else and try to paste, JMP will be upset because it noticed that the type of data I was trying to put in each column was wrong. So again, let me show you where I did that from. So let me start my new table. I'll just start from scratch. New table, paste with column names. And then I took those next 10 rows. A ghost is making coffee. Click in just one cell and hit paste.
Anyone wants coffee?
It's now in the reservoir at the bottom. All right. So be aware of selections. That's one that I know catches a lot of people. Any questions on that?
Can you just repeat because I didn't?
Oh, absolutely. Yeah. Yeah, the ghost. So we'll delete those rows. So copy from anywhere, and then make sure you click in just a blank cell. There's not even a row associated with it. Just click in the blank and hit paste. Yeah. All right, so copy and paste. Finally, remote sources. I don't want to spend too much time on this because I think we're right on time, actually. Database queries. JUMP works with any database you want, ODBC compliant. You'll have a query builder, which we're going to look at in a little bit. JUMP will actually write SQL for you, which is really nice. So I'll show you that when we actually work with our local tables. Does everyone know JUMP can pull from web pages? Has anyone never tried that? So this is nice. Under Internet Open, there's an option to select a web page. And I'll just give you an example. Let's do, I'll give you a United States example. I'll do state birds. Do you have state birds or birds for regions? I don't know why we do this. We have state birds. So we pick birds that we like, I guess. I don't know. So here's a table of our state birds. Some of them are just turkeys. So not very cool. I grab the URL and I paste it into JUMP. Now what JUMP will do is it'll look through that web page for tables. There's a lot of tables on Wikipedia. It uses them for formatting. I'll just let it pull everything open. It turns out the last one was the list of state birds there. And what it's done is made a table where it has every column it found. And it also did something kind of interesting. It went through and found the photos. And actually there's a script in the table. And this is something very nice if you have web pages with tables with images. JUMP can actually go to that website, pull down every image, and it can stick it in as what's called an expression column. And so your birds can now be a part of your table. So there they are. And so I don't know if any of you have data where you may have an image that's representative, but this is a data type that was added in JUMP 12. It's called an expression data type. When you make a column, you just say it's an expression, and that allows you to drag images in. And so we see this often. People want to use an image as a marker. And so if I were to make a graph, I could have the marker be the actual picture of a bird. But so if you have data that's on a website anywhere, Internet Open is a really useful way to pull those data in. And again, the source, because it's pulling from a website, it can actually pull new data. So if that data changes, you can just run that and pull open the new data. Now there's another way to get data in that's similar to a website, but it's a Google Sheet. Does anyone use Google Sheets? Sheets.google.com? Yeah, so you can put in your Google account name and the URL for the Google Sheet. It'll authenticate you, and you can bring those data directly into JUMP. And we use this a lot when we're working with survey data, because we can have people fill a Google form and just pull the data down in regular intervals. And the way this is built is something new that was in JUMP 14, which is that JUMP can work with REST APIs. So these are websites that have what are called endpoints, places that have data where you have to usually exchange some kind of token or an authentication, and then you can pull data. And so there's lots of endpoints that are free. You can pull weather data down into JUMP. You can pull street maps into JUMP, things like that. But the REST API interface is pretty effective inside of JUMP. So that's REST API and Google Sheets. And so we'll play around with each of those a little bit more as we go on. All right, so I'm going to leave import unless there are any questions. Yeah?
When you delete, at some point when you deleted the values,
Uh-huh.
it showed a little black dot. Can you explain what it is?
Oh, absolutely. So if you have a table and you delete numeric data, so data that is actually numbers, the way JUMP wants to represent the missingness is that black dot. And that's just to let you know that there are rows there, but they have an empty value. Now, if you delete data for a row that is text, oh, I can't delete, I'll do this one. That was a formula column. So I deleted a text column. The way JUMP represents blanks for text is just empty.
But it doesn't affect the analysis that you're missing. I mean, obviously you're missing some points, but
Right.
beside that,
Besides that, it's as long as that column is not being used in the analysis, then it won't affect that. Yeah, and so this is pretty common. Usually JUMP, it's called missing cell-wise or column-wise. So if the analysis doesn't use cite in this example, then it won't even pay attention to the fact that those data are missing. Yeah. Yeah. And there was another question. Yeah.
About finding of the date.
Uh-huh.
In German-speaking word of the era of the word.
Uh-huh.
So we have the different way of day and month.
That's right.
And by default, usually JUMP imports the date in the wrong way.
I believe that. Yeah. Let me pull open a file here, see how we get you. So when you import one, so these were those data I had. Actually, what was the data I used where I had, I guess it was temperature. That was the easiest one. Let me pull open that temperature file again. Just so we have some unformatted dates coming in. All right, so often, if you have data coming in like this, where the date is actually already numeric, let me do it as 12. So these are like epoch dates, so they're dates since I think it's 1904 at midnight on January 1st. When you format that as a date, so I can do date here, you should be able to design day, month, year. And so as long as it has that epoch date already in there, it'll allow you to switch them. And so that's January 5th. I guess that's right, yes. Now, if you want to bring that data in, let's say this was copied from the table. Let me see if I can copy that formatted date. I want this to come in as text. So let me actually take this over to a JSL file, take it back. A new file. It's really going to be happy with those being continuous. Well, I'll show you what I was going to say. So when you format the date, that's the selection there. The input format is where you would say what it came from. And so here you would actually have to say that it came in as day, month, year, and you want to format it as month, day, year. Yeah.
I know this, but this is an extra step I have to do every time.
Yes, that is frustrating. You would hope that, and I assumed in our date time preferences here, that you should be able to specify regionally where it comes in from. But I just searched date in the preference group to see if there's a setting for this.
It's only for text files.
Is it only for text files? Okay, so Martin would know.
That's some requests which was sent to the developers already. Because the most important thing is sometimes you get the data into JUMP already wrong or missing at all because it's just not matching the default settings.
Yeah.
I also asked, will again, I wrote it down, talk to the developers that we have some option that we can specify the default input.
It should be specifiable. I agree. Yeah. Yeah, we'll yell at them on your behalf. And I should mention, if you run into things that are frustrating, like please let us know. They are really, really responsive. I'm amazed by our developers. So yeah, please always let us know. One additional point, how many of you are members of the community? Community.jump.com? Maybe only a few. One really good reason to be a member of community.jump.com. Oops. Community.jump.com. I can type in public. There we go. Community.jump.com. There is the wish list. So if you're at the community, you can imagine what it looks like. There's a button for wish list, and you can submit a request. And our developers always see these and take them to heart. So if there's things you would like to have in JUMP, you can just submit them here as well. But reach out to us. Like we're probably the best conduits.
Maybe as another workaround, read in this text column, this date column as a text. You can then switch it to whatever format you want, as Julian has showed.
But it is frustrating to have that extra step. Yeah, I'm with you. Yeah. Okay, I want to point out just a few things with column names. We already saw ways of fixing when you have that first row, but I don't know if any of you have this trouble. Sometimes people pass me data sets that look like this, where the columns are just numbered, 1 through however many, in this case 26, and then they give me a separate file that has my list of, like a data dictionary. And I don't know why people do this, but this is something that I see often. And so if you find yourself typing them in, there's always an easier way. So Jump actually, for a long time, has made this easy. You can just copy from that data dictionary, from that text file, select the columns in the table on this side, and then just hit paste. And the way this works, notice when I select different sections, the header selects here. So when you select in the columns list, you're actually selecting almost like a list of columns in this side. And so that means that you can take them out of Jump as well. So if you have, let me just grab a few of these so you trust that my clipboard is only those. So I'm going to just go to Jump here. I can select them all, copy, and now I can paste the column names out of Jump as well. And this ends up being really useful. We've asked, or we've heard people say, what if I want to put a number at the end of my column? So I want to increment in some way or put something on all my column names. You can use your column names like data. So if I make a new data table, paste my column names, I can make a new column and say 1, 2, right-click, fill down. So now I have manufacturer all the way down through the end, 26. Grab the 2 columns. I'm going to show you this in more detail later. I'll concatenate them using an instant formula with a space. And now I can just take all my column names, go back to my original table, and paste. And so now that's a part of the column name itself. So it ends up being really useful that you can treat column names like data. And you'll find often with the data dictionary type things, that becomes a huge time saver. Now there is one new thing in Jump 15 I want to show you, which is that you can treat column names as data for the Recode platform. Has anyone used Recode before? Recode in Jump is where you can right-click on a column and go to Recode, which lets you change names, change values, group things together so you can group a bunch of things to one category. So we'll play around with that in a second. For column names, you can do the same thing now. Under Columns, Utilities, Recode column names. And the value of this is that you can treat your column names as if they're values in the table that you want to recode. So for instance, I've seen some people where you have to give your data set with no spaces in the column names. Some software has real problems with that. So you need to go through and fix all your column names to be, let's say, no spaces and lowercase. So in the Recode, I can say, well, convert them all to lowercase, and let's remove the white space. And so now my column names are, this squished together with no space. I'll hit Recode, and now Jump has recoded the column names in the table. So it makes it really easy. Other times, if you need to recode, so I'll go back to Utilities, Recode column names. There are times you have columns in your table that are one name, but you have a different table that says what they should be. Like maybe it's the translation of your column names. And so there's also the option, and we'll see this later on with Recode in general, which you can apply a mapping from a table. Essentially, you can give this table to Jump and say, take this value and make it into this value. So it's a really nice way to recode quickly. All right, so that's under Columns, Utilities, Recode column names. That's brand new in Jump 15. All right. Any questions on column names before I talk about metadata? Okay, so let's talk a little bit about metadata and what it is first off. Let me just pull open a simple file. So those of you who are brand new to Jump, you may not have known, but Jump is really concerned with knowing what type of data you have in each of your columns. And the reason why is when Jump first started, the idea was to make the interface as smart as possible, to give you the type of analyses that make sense for the data you're looking at. So for example, I'll go to a simple platform, distribution. I'll give it 2 different columns, tip amount at these tables, and whether a credit card was used. And the first thing Jump does is it, based on the type of data in each column, gives us different output. For the column that's tip amount, it's giving us a proper histogram. I say proper because they're bins that I can resize. So it's proper in terms of a histogram. And it's giving us quantiles of summary statistics, numeric summarizations of the data in that column. For credit card, we really just have yeses and nos. It's categorical. So it gave me a frequency distribution plot, and it gave me a frequencies table. So JUMP has already shown different graphs based on the type of data. And for those of you who are new to JUMP, you probably also are starting to see that the red triangles are really important. Click every red triangle as you're learning JUMP because they give you the options to do more analysis. But what's really smart is that JUMP will show the types of analyses that make sense based on the type of data you have. So for tip amount, which is numeric and continuous, I can do things like getting a normal quantile plot, or I can do things like testing a mean. Maybe for some reason historically the average tip amount was $4, so I can get a z-test or a t-test from this. Okay, so for the credit card column, which is categories, I don't get any of those options. I get the option to test probabilities. So maybe historically 50% of the tables had used a credit card and 50% didn't. So I can test the probability difference. Or I can get a different way of displaying the categorical data, a mosaic plot. Right, but JUMP has given us different options for the different types of data. And the way it accomplishes that is the metadata. So basically how you tell JUMP to think about these columns. And it's listed in two places. So first in the columns list, these are active, so you can click on the bill amount blue triangle and see that it's continuous. You can set it to something different if you want. And for credit card, you'll see it's set to nominal. Nominal just means categories, names only. Continuous means something actually numeric and something that should be measured on a continuous scale. Now, I just mentioned one thing. There are times where maybe you need to change this around. You actually need to tell JUMP that a numeric column is actually just categories. You most often see that on survey data where somebody maybe answered, what region of the country are you from? And it's stored as 1, 2, 3, 4, and 5. But it's not really numeric, 1 through 5. Those are categories that you've just chosen to store as numbers. So you may have to go in and tell JUMP that it's nominal. Now there may even be times that you want to take a numeric column like tip amount and treat it as a category. And I'll show you one example. So if I treat it as a category, it's going to give me a very different plot. It's treating every unique value in that column as a category. But you probably already see something pop out. You see these particular values that are really high occurrence. And those are the dollar amounts, the whole dollar amounts. So $1, $2, $3, $4. So maybe your hypothesis is that people, want to round up or leave whole dollar amounts. They don't want to be the jerk that leaves 74 cents on the table. Because we tip a lot more in the US, I guess. So it's seen as rude, right, to leave that penny. Or the person who left $4.02. Didn't you get rid of pennies, or was that the euro? Or the euro cents are gone, right?
No, the penny is gone in Germany.
Okay, yeah, Brett's really smart. Yeah, we still have a ton of them lying around. I don't know why. But so this is just a point to say sometimes you are smarter than JUMP, and you know that a column needs to be a particular modeling type, it's called. But normally JUMP makes pretty good guesses. All right, so modeling type matters. And modeling type is the thing on the left-hand side here. Or if I right-click a column and go to column info, it's listed here at the very top, modeling type. Now I just want to point out there are a few other pieces of metadata that matter. Metadata meaning data about your data. The other one is data type. Data type is how JUMP is actually storing the values in the table. Is it storing it as numbers? Is it storing it as a string, character, or some specialty formats? And then modeling type is how do you want JUMP to treat the data in the column? So that's something you typically change. This is also where you set formatting, so currencies. And this is also where you set really important column properties. So for instance, let's say we were making a graph and we were looking at our servers. So we have servers A, B, and C. And we were looking at, the average tip amount that each server gets. So I'll actually look at it like this. So there's the average amount of each server in terms of tips. But let's say you wanted to have server C listed first, then server A, then server B. For some reason. Maybe that was just the order in which they joined the restaurant, or for some reason you want to switch the order. So if you want to change the order, you're not going to find the option actually on the graph here. You can order by count or order by the tip amount, but you can't set a specific order in a graph. And you'll also notice that the order here is exactly the same as the order in restaurant tips, the distribution. So if I pull up in a distribution of that. Now the way Jump is doing this ordering is based on a column property. And so just so you know, under column info, let me go to server here, column info, there's a column property that's called value ordering. And this is probably one of the most asked questions on our community because a lot of new users are confused why the option to set the order is here. And I'll show you how to change it, then I'll address that question. So I'll put C at the top, A second, and then B at the last, and I'll hit apply. And notice that my graph switches around instantly. Okay, now why is it here? Why is it not just on the graph? The reason why is because every graph in Jump is linked. So it makes some sense to have that property be a property of the column. So anytime I launch a graph that uses server, now it goes CAB. If I do an analysis with fit y by x and look at that by tip percentage, it's going to be CAB. Right? Every time I do anything with the column server, it now honors that column property. So often, and this is just something to remember about Jump, often when you're looking for something that has to do with the column itself, that'll be in the column info. That's in that column properties there. And just so you can see, there's a lot of them here. So if I look under column properties, when you set a formula, the formulas are here, value labels, value orders, value coloring, it's all here in the column info. So something you might not have known, your data tables themselves can be little graphs. So if I set a property, and this is one I really like, I'll do value colors. You can set a color for each server, and I'll color the cells by a value. This is really nice if you have something that shows something is out of spec, or you've got to look through your table and see it really quickly. It also works really well for quantitative columns. I'll go to column info, column properties, and set a color gradient. And so for instance, maybe anything above $30 is bad or good. I don't know. We'll say bad. I'll set it to red. Red seems bad. So minimum and maximum, and then the center point. And so, oops, I didn't color by the cells. So make sure to click color cell by value. And now I can spot really quickly if something was high. So this is a nice way to use your table almost as a little graph as well, to make it informative for you, to decorate it in an informative way. All right, so value ordering was a really important column property, but there's lots of column properties. All right, finally, we sometimes have tables where there's hundreds, if not thousands, of columns, and you need to set a property for all of them. Here's a good example. I have 128 process columns. So a lot of data and a lot of things. And what if they all have decimals and maybe those are nonsense? The significant figures here doesn't make sense to have that. What if I want to set a format for all of these columns to not show decimals? You could go through column info to each one, go to format, say fixed decimal, and say 0. You could do that, but that's very slow. And I'll tell you in Jump, if you're ever doing anything repeatedly, there's probably an easier way because somebody else has ran into this problem. So the way to do it in Jump, select all the columns you want to standardize, right-click and go to this really great option called Standardize Attributes. And Standardize Attributes gives you a control panel. And the control panel lets you decide what is it that you want to standardize. And I already told you, I want to standardize the number of decimal places. So I'll go to Attributes, say Format. Now the Format field becomes active because I can standardize it. And I'll say Fixed Decimal with 0 places. When I click OK, it goes through all the columns and sets that value property. And this becomes really useful. So let's do another one. I'll go back to Standardize Attributes. What if I wanted to standardize a column property? Let's do that color gradient. And let's say these properties all have the same issue if they're above, let's say, yeah, if they're above 120, that's a real problem. Otherwise, 0 all the way to 70 is not a problem at all. So I'll standardize and I'll color the cells. So I'm going to click OK, and now we'll go through and actually do it. They're all on different scales, so this is maybe not the best example of where that would be used. But at least you can set the property for all of them all at once. So standardized attributes is very, very useful. It's something to remember anytime you're applying something to a lot of columns. And so we'll look at that again a little bit later for setting a formula. But for now, that's a really useful data table setup tool.
Excuse me?
Yeah.
The negative values didn't get rid of the comments.
Look at that. I don't know. Did I not select that one? No, I must have. Good spotting that. I wish I had like candy to give you. That's normally for like good questions. We're like, oh, good job. Let's try it again. So attributes, format, fixed decimal, 0. Okay. Wow. I don't know.
It's a string, probably.
Oh, maybe it is. Nope, it's numeric and continuous. If I force it, let's try fixed decimal. Wow, that's interesting. I don't know. Yeah, I'll look into that. That's some little funny thing that happened there. Good spot. The troublemaker in the room. Yeah. You're like, but it didn't work there, did it? Yeah, it's very good. All right, so standardized attributes usually standardizes attributes. All right. Yes?
Is scriptable? Is standardizing?
Is it scriptable? That's a good question. I believe so. Let's look in the scripting index. Attributes. I haven't actually ever tried to script it. That's just regular standardized. I'm willing to say you could script it in certain ways. Almost all Windows and Jump you can script just by sending a message to it. But it doesn't look like it's invoked automatically in scripting. That's a good question. I can look into that for you and get back. Worst case, you can of course write a loop, but it would be great to call it as a function. Yeah. Yeah, good question. All right, so I want to show you in this last little section here the idea of doing table views and filtering. Because there's often times in Jump that we're working with only a part of our data, and it's normally not the best practice to delete data or work with a small bit of your data. It's nice to have that all in Jump and use a filter. And so I want to talk about really 4 separate things. So data filters, global and local, and then special variants of subsetting. So proper subset is something called the data view, which was added into Jump around Jump 4, but it seems like a lot of people forgot about. So it's a really, really useful thing. And then we'll come back and talk about the row editor, which is a very specific way of looking at data. All right, data filtering. So for instance, if we use this restaurant tips file we were looking at before, and let's say we had a graph and we were looking at, I don't know, a day-of-week effect for bill amounts. So we're saying, how much do people spend each day of the week? So let's say we have a graph we like, but we would like to look at it separately for servers. That is, we want to see for server A, B, and C separately. We could, of course, make that a part of our graph. We could have server as a wrap variable. We could overlay. We can do lots of things to look at there. But what if we really only want to consider those data in this graph? All right, so we could do one of 2 things. We could apply things to the table, metadata. We could exclude cells or hide cells, or we can use a filter. Let me start by showing you excluding. So let's say we wanted to look at just server C. So I'm just going to grab servers A and B and do this operation called select matching cells, which is really, really fantastic. It'll select in the table all the A's and B's. And now I can right-click and hide and exclude. If I did that, if I hid and excluded all the server A and B's, I'm only looking at C then. And just to be clear, hiding means not showing a point in a graph, and excluding means not using a point in a calculation. So you can actually do one or the other. You can just exclude or just hide. Normally you do both. That's why there's the hide and exclude double option. But it is true that you could hide but not exclude if you really wanted to. All right, so that's kind of manual. And so let me show you a really useful option under the rows menu called the data filter. And what the data filter does is gives us a control panel for applying what are called row states. That's what had happened when I excluded and hid the rows. It gave a row state to each row. So I can say, use the server column. It's asking me what column do I want to use, so I'll use server. And we have three things that the data filter can do. It can select rows when I click on people. It can show those rows when I click on people. And notice that anything that isn't clicked on, it does the inverse, it's hidden. And it can include rows when I click on them. So now when I click on A, all the A servers are selected, and B and C are excluded. When I click on B, A and C are excluded and hidden. And I click on C, A and B are hidden and excluded. So a way that I often use it is using show and include checked. And now, if you look at my graph, when I click through server A, B, and C, it's showing it just for server A, B, and C. Now, the benefit of using the global filter is, let me see, I've selected A, and let's do one more thing. I'll click and let's look at people who use a credit card. So server A and credit card use yes. So I could have multiple categories. If I go to another platform, let's say I go to FitY by X, and I want to look at the relationship between tip amount and bill amount. When I do that, that new platform, that new result, is also using just server A and credit card yes. So we call this over here the global data filter. And it's global because it is applied to the table, a row state, and anything that happens after I apply that row state uses those exclusions. All right, so compare that, if I hit clear, compare that to what's called a local data filter. So if I'm in a graph or in an analysis, and I go to the red triangle and select local data filter, it's a part of every top level red triangle. I'll have something that looks very similar. It's a little local version of the data filter. So I'll select server again, and I'll even select credit card. It works the same way. I can select server A and credit card yes. But now if I go to another platform, I'll do the same thing I did before. That's actually all the data in the table. So this local filter only applies to this graph. I could do a separate local filter on this graph. I could say, give me credit card and server again, and this time I'll do credit card no and server B. So the local filter is nice because different graphs can work with different subsets. So just think about which one's going to be useful for you. Oftentimes the global is good because you've selected and excluded for some reason that you want every graph to adhere to. But sometimes the local is better because you want to have little controls. One thing I'll say, the local data filter, if you save a script from this analysis, I'll save it to a script window. You can save a script to lots of places. But if I save it to a script window so you can see what it looks like, you'll see that the local data filter is a part of it. One big value of that local filter is it's always a part of the script for the analysis. So if you were to share this with somebody else and they ran that script, it would apply that filter. So maybe something you want to consider. Okay, so that's the local data filter and the global data filter. There are times, though, when you really want to have separate data tables based on some characteristic. So it could be that you want separate data tables for servers A, B, and C. Or maybe you want a separate data table for the first 10 rows. So let's look at both of those. I've selected the first 10 rows, and we're going to use the option called tables subset. And subset does just what it says. It takes a subset and makes a new table out of it. Subset has several controls. The first is to decide where the rows come from. Do you want your selected rows, a random subset in some way? The next option is what columns. Do you want your selected columns or all the columns? And the final options are, do you want to copy formulas? Do you want it linked to the table? I'll show that in a second. or other options like that. I'm going to leave everything at the default and click OK. And notice Jump builds me a table with those selected rows, just those 10. So now if I do any analysis, maybe I do that same graph, it's only showing me for that 1 day of week I have, right? Because I only have 1 day of week. So that's a subset. Subsets are great for pulling out parts of your data. I'll show you a really useful option. Under Table Subset, there's the option of subsetting by. What that means is you have some column that identifies groups in your table, and you want to have separate tables based on those groups. So what about using server? If I do that, I get 3 tables: servers A, servers B, and server C. All right, so I can save these out. I can provide these. Maybe that's just really what I need from this project. I need to break apart all the tables. So this is a really nice way to subset by another variable. Now, just so you see it, there's a version of that by in every analysis as well. So if I go to distribution, and we were looking at, like we were before, tip amounts, notice there's the by section as well here. So without subsetting the table, I can also replicate that behavior by putting server there, and it'll give me 3 graphs separated out by the server, servers A, B, and C. So you can use by in a lot of different places, but that's worth knowing. All right, so there's times when you just want an impromptu subset. You want to take a small bit of your data and work with just that. For instance, what if you were, here's an example. What if you were looking at the tables that had a really high tip amount? So you saw that there were some tables up here that were just, tipping a lot of money. So you selected them, and in Jump, when you select anywhere, they're selected in the table. So with them selected, there's an option at the bottom. Sorry to zoom so quick, that makes people nauseous sometimes. You can right-click and do something called the Data View. And what Data View does, when you right-click on anything, either selected, excluded, hidden, whatever it is, when you do Data View, that pops out a mini subset that's linked to the table. And it's linked because, watch what happens when I select, it actually still selects in the table. And it's linked so you can change values, and it changes the original table. And this ends up being really useful if you have strange points you need to interrogate, and you say, oh, this table that had a $15 tip, that was actually a $5 tip. And if I change it here, it's going to change the original table. So sometimes when we're working with millions of rows, you just want to look at the 10 that are strange and work with them. So again, you can make any kind of selection you want, right-click on the selected section, click Data View, and that pops them out as their own linked table. Yeah?
Can I ask if it's somewhere recorded the changes that you've made to the original data?
It just makes them directly to the table.
So you can't see anywhere what you've done.
There's no log. No. That's a great question though. So one thing we've found, there's good habits for storing saved versions of tables. We have a lot of customers who use a SharePoint site, and the SharePoint will actually save version histories, which is really quite useful. And there is the option, what I actually do is I save a separate version every time I make any big change. And there's the option of compare data tables in Jump. So you can actually see what the changes are from version to version. Right, but there's no inside of Jump history of a cell. Yeah, that's a great question. I would love that personally as well. Yeah, so that's a linked subset. I want to show you one more view of data that I think is really cool, and I think a lot of people forgot about. If you're looking at a table that has a lot of values, let's go back to that semiconductor capability, and you want to look at all the data for row 7. You can actually just double-click row 7 and pop open the row editor. So this is row 7, and this is every value in that row. Sometimes this is very, very useful. I'll give you one obvious example. I was working with some professors, and they use Jump for their grade books, and they don't want to show their students everyone else's grade. So they'll use the row editor because they can go to that student, double-click, and just see that student's score. That's a very obvious way to use it. But there's times when you just need to interrogate that row, and these are editable. So you can change the values, the changes in the table. It's a nice way to see all the data for a single row now in just a list. And so you can click through different rows. You can go to the last row, first row, etc. So it's a really,
You get there.
yeah, just double click a row. Yeah, it's been hiding in jump since I think version 3 or 4. Yeah, it's been in there for a while. There's lots of things like that.
And what's blink?
Oh, good question. So let's say you're on row 17 here. If I click blink, it'll blink it in the table.
Oh.
Yeah.
okay.
It's more obvious than you think, right? Because I saw that too. I was like, what could blink possibly do? Yeah, it blinks. Yeah. I'm not sure why, but it's sometimes, yeah, it's useful. I guess if you need to find it.
Sometimes you get blind, it's useful.
Yeah, that's true.
Or you get-
There's a couple really important, this just reminded me, let's say you have a couple rows selected far down in the table. Have you ever had this when you're scrolling, trying to find your next selected row? So there's really good keyboard shortcuts in Jump. A command, and on the Mac it's Command Shift bracket. That'll actually go to the next selected. And so if I do that, it just goes to the next selected row, which is really valuable. So I'll give you the most obvious case. You've looked at a distribution for your processes, and there's maybe one place where you're like, that's a really extreme value. Like those are really extreme. So I've selected them, and now I just want to go look at them. And so I can click and keep going. And this is a great place for data view, right? Instead of doing that, just pop them out. There are those rows that looked suspect, and now I can work with them. By the way, once they're in this data view, the graphs you make only apply to that. So now I can look at, for all the different processes, I had 128. Oh no, it's going to pop this up for every one of them. All right, well, I'm going to talk while I keep pressing this. So when I go to distributions, oh good, it only did some of them. It'll show me for all in that table alone the values on the other variables. So data view is a really, I think, indispensable tool to look at pieces of your data when preparing it. All right, so those are some table views. So I said 30 minutes for that, and I did an hour, so we're doing great. Okay, data restructuring. And we can come back in question and answers for any of that, but I would feel bad if I didn't show you some of these. So there are times when our data come to us in formats that aren't quite right. So they're not exactly the format that'll let us analyze it. I'll give you a simple example. So here are some data on histamine levels for several dogs. And just so we can see a little more clearly, I'm going to get rid of some of the extra columns. So what we have are our dogs 1 through 16. They've either taken morphine or another type of drug, and we're looking at their histamine levels over time. And suppose we wanted to make a graph where we were tracing the histamine levels separately for each dog. So we want a line for each dog over time. And we want to do that separately for the different drugs. It turns out that that's really hard to make when you have the 4 histamine levels as separate columns. What we really want is a column that says time that we can use on the x-axis and histamine levels that we can use on the y. It turns out there are ways you can force jump to do it using something called a parallel coordinate plot. It's a special kind of plot in jump, so you could hack your way to it. But it'd be a lot easier if we had a column that said time and a column that said histamine level. So this is something where we need to do a stack. We need to reorient the data so that we have columns into rows. And so let's hide that for a second. I want to show you a simple example of this. And I just built a table that had us some certain properties that lets us see where the cells go. So we have a column that actually says row number, 1 through 4. We have columns A, B, and C, and then I've labeled them A1, B1, C1, etc., so that we can see where the cells are going to go. So stack in Jump is under the tables menu. So I'll go to table stack. The control panel actually only needs one thing from us, which is for disasters. It only needs one thing from us. Which columns do we have data in that we want the data to be across rows? And so if we look at our table, columns A, B, and C have the data that we want to now be across rows. So I'm going to put those into the stack column section. So that we can go back, I'm going to click Keep Dialog Open, and I'll click Apply. And so I want you to compare these two tables. row 1 here had A1, B1, C1, is now represented across rows 1, 2, and 3. So A1, B1, C1 are now vertical. And notice, if I really wanted to look at A1, B1, C1 over time in some way, I now have a column label that defines my x-axis. So I've just shifted the values. So row 2 is now these 3 rows. Row 3 is now these 3. So I've stacked the data. Now I want you to notice where those column headers came from. Label was what JMP referred to as the source label column. And data is what JMP referred to as the data column. So for instance, what if these were parts per million measurements for 3 different processes, right? So we could do this stack and actually label them appropriate. So I'll hit recall, I'll say data is ppm, label is process, and now JMP will properly title my table, process and ppm. All right, so imagine that we had a table like this, process and ppm, and we needed the data to be in that original format. So we needed to go the other direction. So the opposite of a stack is a split. Take columns, or take a column that has data and make it across rows. Sorry, take rows of data and make it across columns. And so again, under tables split. We need to tell JMP a few more things because to unfold the data, it takes a little more work. We have to tell JMP what defines the rows. We have to tell JMP where the data actually live, what column has the data that we want to be in the data set, and then what column is going to define the column names. So that's actually metadata. So in our case, row defines really the rows of the new table. Technically, we don't have to use this. JMP will figure it out, but I like to always put that in if I can. Process, that column is going to define the column names, A, B, and C. So that's the split by. And then ppm actually has the data. That's process. Sorry, ppm has the data, and that's the split column. So I hit OK, and notice that we are back to our original table. It's again just moved the data around. Now this is maybe really useful. There may be times where you want to calculate a row-wise average or something like that across these data. Maybe there's some reason you need them stored wide like this. I find often that the stacked format's more useful, but you'll get usage out of each of them. So stacking and splitting. Does that feel pretty comfortable? So let's look at it with our dogs data. So in this case, we have 4 measurements that we need to stack. So I'll use table stack. Only thing I have to give JMP are those columns. The data is actually histamine level. And the label, what defines those levels, is time. So now I have a table that has a time variable, and now I can make that graph. So if I go to Graph Builder, it's really as simple as histamine level on the Y, time on the X. I wanted lines connecting them, but I wanted those lines separately by dog. So overlaid by dog. And we could actually do them separately based on drug. So I can color by drug here. And so now I actually have for the trimeth and the morphine. Right, so it enables you to make graphs. It also enables analyses. You know, this is an analysis where the X would have to be histamine level. And I'm looking at the effect over time. So having that as a variable is really useful. Okay, any questions on that basic stack? 1 column across rows. Briefly, I want to show you an option that you may require, which is a multiple series stack. So sticking with the way we talked about the table, let's say A, B, and C is still process, but A1, B1, C1, the 1 here refers to parts per million, and the 2s all are yield. So different types of measurements, but we have them for each process for each batch. So ppms and yields. So what we want is a table that's rows. We have each batch. We want 1 column for parts per million of some measure for the different processes. So we have a column that says process. And we also want yields as another column for each of the different processes. So this is what's called a multiple series stack. We have two series. We have parts per million and yield, and we want to make them across rows. So in stack, we have an option for this. And I'll zoom in so you can see it in the back here. We're still going to use all of our columns, A1 through C2, but we're going to use this multiple series stack option. And the way this works is we have to tell JMP how the columns are oriented. Do we have the PPM data and yield data next to each other? That's what contiguous means. Or are they interleaved for each process? Do we have process 1 or process A, parts per million yield, and then process B, parts per million yield, process C, parts per million yield? That would be interleaved. That would be non-contiguous. In this case, we have two series, parts per million and yield, and they're contiguous. All the yield data and parts per million data is next to each other. So when I click OK, JMP unfolds this. Let's look at them side by side, such that A1, A1-1, B1-1, and C1-1 are all here. Those are the parts per million for process A, B, C. And then yield data, A2-1, B2-1, C2-1, those are down here. So it's just reoriented it, but now with yield and parts per million separately. Okay, here's my bit of advice. Whenever you do, especially a multiple series stack, make sure you check the box for keep dialog open, this thing right here, because I've been using JMP for 16 years, I still get this wrong, and it's just frustrating to go back. So keep it open, because if you don't check the right thing or have the right number, it gets all wonky. Like here's what it looks like if I didn't check contiguous. I have A1-1, C1-1, B2-1. I mean, it's just all over the place because it's trying to unwrap the data such that the parts per million and yield data are interleaved. That only works, so if I go to our table, that's only going to work if I have them oriented like this. So you can see if I have A1, A2, B1, B2, C1, C2. If they're like that, then they actually are non-contiguous, but two series. So it will unfold them now again. So keep dialog open, pretty indispensable. Keep that there. I'll point out something that's been in JMP forever and something that's new in JMP 15. So in JMP forever is when you click apply, there is a source script saved to the table. Remember when we did table import? We got source scripts. When you do table manipulations, operations like this, you also get that source. And if you look at it, that's the script for doing that stack. So it says, here are the columns, here's how you do it, are they contiguous or not? So you can use that script and run it again. It'll hit the original data and make that table again for you. So that's been in JMP for a while. What's new in JMP 15 is there's the option to save the script to the original table. And this ends up being really useful because if you're doing this stack, but you're not really keeping that final table, you just did this as a part of your work, you want that stack script in the original table. So it's actually right here now, stack script. In the past, it wasn't hard. You just went to this table, right-click, copy, go to your original table, right-click, paste. But why make an extra step when we can check a box? So it's one click less. That's good. So just to be aware that in JMP 15, that's an option now for a lot of the table operations. Save script to source table. All right, so that's stacking and splitting. Let's talk about merging, because oftentimes we get tables that are separate, but we really need them all together so that we can do the analysis we want to do. And I want to talk about really the most simple type of data merging that we could possibly have, which is concatenating. And to motivate it, let's remember that restaurant tips file. I'm going to do a table subset like we did before. I'm going to subset by, let's do servers. And let's imagine that these are the data that we were given, separate tables for server A, B, and C. For some reason, every server gives us the own table. If we tried to go to a graphing platform and we wanted to use server as a variable, we don't have it because these are separate tables. And JMP, the way it works, right, is that the data that's in one table is what's available for the analysis, with few exceptions. So tables concatenate is the way to bring tables together row-wise. That is, you have rows from different tables, but the same columns generally. So we launch concatenate, and it's probably one of the more straightforward joining or table operations. It just tells us pick the tables from what you have open that you want to be concatenated. And so I picked A, B, and C. And jump will, if I click OK, it'll pull these tables together. Now, like we did when we imported from Excel and concatenated, I'm going to suggest you create a source column. That you create a column that's based on the name of the files you have. Because when you do that, I'll click OK, it'll write you a new column that says source table. What table did these data come from? It turned out we still had a column called server that was in the table already, but I really think this is a valuable thing. You could always delete it if you don't need it later, but it's nice to know where the data come from in case there's something ambiguous. So I think it's always better to have that. So concatenating is pretty straightforward. That just takes data row-wise from different tables and builds you a tall table from it. The other types of joining or data merging are a little more complicated. And so to motivate this, did you all have Blockbuster in Switzerland or Germany? You guys know what Blockbuster is? They're the now defunct movie rental store. I think there's one left. There's one left in Alaska, I think. It's literally just like a museum now for Blockbuster of times past, DVD rental. Anyway, so let's imagine we work for Blockbuster. So now we're early 2000s, late 90s. And we have 3 different systems that manage our movies. So we have a system that manages the inventory. So this is only 112 movies that we have at our little Blockbuster rental. But this has the name of the movie, the year, the rating, whether it's a classic or not, whether it's, what genre it is. So, basic details about the movies. We have another data set which really comes from a totally separate database that manages our customer data. Their IDs, gender, sex, or gender, state, married or not, kids or not. So that's a totally different customer ID system. And then we have a 500,000 row data table of all the rentals we've ever had. So this is for every rental that's happened. We have what date it was, what movie it was, like who made the rental, what the item was, how much they paid per night, and the number of nights they had it. So what if we wanted to ask this question? What if we wanted to say, what proportion of our movies are from each genre? Dramas, rom-coms, musicals, etc. We already run into a problem, which is that, or sorry, I should say, how many of our rentals, how many times we rented a movie, which is the most popular? We run into a problem, which is we don't have genre as a part of rentals. It's not in the same table. So in order to ask that question, to do it statistically or even just do it numerically, we actually have to get genre into our movie rental data somehow. And I'm going to talk about a couple ways we could do this and other joins we can do. But I'm going to use 2 operations first, and then we're going to look at a way that actually lets us do a lot of things all at once, which is Query Builder. But first I'm going to use join. So join is a pretty standard operation in JUMP where we start with a table we want to end with, the final table, if you will. We'll go to tables and then select join. And the way joins work, just like VLOOKUPs in Excel or anything where you have to merge across files, you have to have an identifier, something that gives us some idea of which rows in inventory align with the rows in rentals. And for us, it's item number. Right? Those are present in both tables. And it identifies for us which data go in each row. So item 1046 here, right, that movie rental was Buried Alive, whatever that is, and it's an action film. So that's action needs to go in the new column right in the first row of this table. So to help JUMP with this, it asks us first that we want to join rentals with what? Well, we're going to do it with the inventory. We're given a list of the columns in each table. And to the right-hand side, we're able to define the matching specification. And in this case, we can select item number in both tables and tell JUMP that those are columns that should match. Only bring data in when you match in one table, the value in the other. It doesn't apply in this data set, but maybe we have item number and batch number as well, like we have to match on something else. you can match on multiple criteria. And that I mean the combination of those two have to both be there for it to match. So you can do that, but in our case, that's not something we need to do. So we're only matching based on item number. At this point, we can actually click OK, and Jump will do this just fine. There's nothing else we have to do. I want to point out a few options before I click OK, but this is actually all you have to do to define that match. Now, there's the option of which table order is going to be the final table. So preserving main table order means keep the rental data and basically add the data onto that. We can update the main table. The main table is the first table you had highlighted when you went to join. You can update the data from the main table with the second table. If you have columns that exist in both tables that are the same name, you can merge them. And you can do a match flag. A match flag says, where did the data come from? Was it only in one table, only in the second table, or in both tables? And then finally, this is probably the most important section. This is how you want to bring data in. Inner join is the default. The final table you get has rows that are in common. So data has to be in both tables for you to get a row in the final table. You could have a situation where you have rentals that have item numbers that aren't in your inventory. And you actually want to have those rows in the table. That would be weird. Maybe those are new movies that aren't in the inventory yet. More commonly, what's called a right outer join, you have rows in the with table, movie inventory, that aren't in the rental history. So movies that no one liked that you still have. So you could have a table that has those and it would just have blanks for rentals. But inner join is the most common. That's just rows in both tables have to match. Or sorry, rows that are in the final table have to come from both tables. I'm going to hit OK. Let's see what we get. We get a 500,000 row table now where we have all the data from the original rentals, but now we also have the data on what the movies are. So we can make the graph we want. We can go to Graph Builder. We can look at, ends up being trivial here, just genre. And we look at what are the most rented movies. So looks like family and thrillers. Cool. So now we know what kind of clientele we have. Now I want to show you a couple different things we could do if we didn't want to do, even though it's not that complicated, we didn't want to use the join platform. Now a very simple way to do this is tables update, which I actually use probably more than join because it just does the very simple thing that we set up there, which is the inner join, when really we are not even that. It just does basically a left join where we just want to add data from one table to another table. So just so you see what happened, I started with rentals. I'm going to update. And I'm going to point it to the inventory data. And just like before, I'm going to say that our columns are matching on item number. So I've clicked on item in both and clicked match. Now when I click OK, it doesn't make a new table. It just, into the existing table I already have, brings in the new data. Now I want to caution you about one thing, or tell you about one thing that maybe is useful for you. When you do tables update, it's going to modify, let me set up what I had before. It will modify columns that exist in that table with the data in the table you're updating from. So for instance, I'm doing the same operation. What if somebody sent me a new inventory table and said, oh my God, all of our ratings were wrong. In fact, all the PG-13 movies were PG-14. That makes no sense. They aren't a PG-14. But if they were, I can do that in place. Let me just recode. So I've now fixed the data. When I do the update, Jump's going to write over the ratings that are in my movie rental table. It's going to write over them with the new values. So now they're all PG-14s. Right, so update is really great when you get updated data and you need to just replace what's in your existing table. And that's the main value of update. It also adds new columns, but the initial purpose was to update the data. So I caution you because if you have a column that has the same name, you may write over data when you didn't expect it. So if you really are worried about that, or sometimes you have columns that are named ambiguously, one value of join, which you saw, was that it made a new table and just built all the columns it found. It doesn't combine anything, it just builds you a table with all the columns. All right, so that was update and join. Any questions on those two? Then we're going to look at something really cool, which is Query Builder. All right, so Query Builder kind of combines the best of all of that with a lot of flexibility. So it's under Tables, Query Builder. And the way Query Builder works, like relational databases in general, you're going to specify a primary table, which can be really anything of your tables, and then secondary tables. And so I'll use rentals as my primary table. And let's put both customers and inventory in my secondary table. Now, JUMP's going to be pretty clever. If I click on inventory, we know that item number is what matches between inventory and rentals, because the items exist in both tables. Customers, on the other hand, match rentals with another key. They match with customer ID. And JUMP figures that out. It knows the relation between these tables. So when I click Build Query, JUMP gives me an option to use any column I have from any of the tables I have to design a table that I want it to spit out. So let's imagine the table you want is all the values from your rentals. So order date, item number, order year, all of that. We get an immediate preview. But let's say I also want the rating of the movie, the name of the person, or name of the movie, year of the movie, rating of the movie. And I also want the, let's do the gender and the age of the people. So those last two are coming from a totally separate table than the inventory table, but JUMP knows how to match because it's matched on that customer ID. And what's kind of magical, does anyone write SQL code? Maybe you've seen it before, kind of ugly. JUMP's writing it for you in the background. So if you want to convince somebody that you do write SQL, design your query in Query Builder and then just send them this and say, oh yeah, this is the query I ran, and that'll shut them up. Yeah, so it's really nice. And so you'll see it's going to update in real time. If I want to filter by something, let's say I want to filter based on the year of the movie, and I say the year has to be greater than 1975, it'll even write that little where clause. So JUMP knows how to write SQL. It's a pretty straightforward language. But the value of this is if you're hitting a database and you don't write SQL, but you do know how to work with Query Builder, which as you saw, it's got a lot of options, but it's pretty straightforward. You can run your queries, build this out, and JUMP will build you that table. And also quite magically, there's this update from database script. So let's say the database changes, or in this case, the tables that are sitting on a SharePoint drive change. In this case, rentals probably, we get more rentals. So I can click Update from Database, JUMP will do all the things it just did and update them again. So it'll build that query and make you a new table, now with whatever the current data are. So Query Builder, it sometimes is overkill. You see it has a lot of options and a lot of things you can do. Many I didn't even talk about. But if you're building complicated queries, it's a very, very useful tool. So that's Query Builder. Now I want to show you one final thing. This was new as of JUMP, I want to say 13, maybe it was JUMP 14, which is the ability to join virtually. And I don't have it on my list, but I think it's too important not to mention. So if you have a situation that's well defined like this, where you have a rentals data set that's very large, 500,000 rows, and you don't want to bring the inventory data into the rental data, because actually that's wasting space. If you think about it, every time item number 1046 pops up, which is 4,768 times, you can see I selected, so it's down there in the bottom. Every time that item pops up, it's going to have to copy the data over. And that's kind of a waste of space. If this table was, 50 million rows, we might actually get into an area where it's just getting subtly too big for JUMP, or slightly too big for JUMP. So there's something called a virtual join, which works like this. In the main table that has the movie inventory data, I'm just going to right-click the column, and I'm going to say link ID. What that tells JUMP is that this column itself is somehow linking rows across tables. So I'm going to designate that, and you'll see it gets a little icon as a link. Now I'm going to go to any table that has item number, and I can right-click, and I can say that references data somewhere else. In fact, that references data in that inventory data. I'm going to click that, and when I do, watch where my mouse is, because something's going to pop up right where my mouse is in the table. It's got this list of referenced columns. Now they're hidden. I'm going to right-click and unhide them. These columns work just like before. They're in the table, but virtually. They're actually not taking up space. What happens is every time jump sees 1046 buried alive, it's going to virtually add in the data from those columns. And I mean virtually, this is all ethereal and non-physical, but virtually in the sense that it's not duplicating the data, it just knows to go looking for it in that other table based on the link ID. So when I make a graph, Jump is actually going to build this dynamically. If I put rating here, or genre I guess is what I used, it's able to count up the number of rows in this rental table, but using that column as a virtual reference. And so this ends up being a really nice way if you have huge data and you need to link by some characteristic and bring it in without joining it. Personally, if the data are not so large that I have to do this, I don't do it. I would much prefer the data actually to exist in one table. I still feel more comfortable with that. But I have a few data sets that are, 300 million rows, and it's just you can't have data that's really wide, so the virtual joins are really useful. All right, so I'll show you again the table that has the data that you want to bring in. Set that as a link ID, whatever that identifier is, and then in the table that you want the data to come to, right-click the column, link reference, and then point it to that table. All right, any questions on those? All right, so in the last 15 minutes, oh my God, we're even close to being on time. I want to show you some data aggregation tools. Now this is sort of a slight departure. We're not often doing this in the service of getting to an analysis. Sometimes this is the analysis. Somebody says, I just need a tabulation of how many times a movie has been rented from each genre or from each type of rating or by year. They just need a table. They need some kind of summarization, and that's actually the output of what you're doing. So I want to show you two great ways to do this. One is tabulate and one is summary. So actually using that movie rentals data, let's try to make that tabulation I just said. So we want a table that says for every type of genre, we want to know how many times it's been rented. We don't want the graph, we just want a table. So I'm going to go to Analyze Tabulate. And Tabulate is pretty neat. All of you have used Graph Builder, I'm sure. But Tabulate some of you may not have used. It's drag and drop table making. So we can just design the table in our head and then drag the columns to the places that we need. So I'm imagining a table that has rows for each genre, and then the column of values will be the number of rows in this table that count as that. So to make the table, I'm going to drag a column, and you'll notice when I drag to different places, it'll actually highlight. And so the drop zone for rows is the place I'll drop to design a table with rows. Now the first thing Jump will do, the simplest thing it can do, is tell you how many rows in this table count for each of those levels. And that's exactly what we wanted. We wanted action through Western, and we wanted the number of rows. I can click Done, and this is now a little interactive tabulation. I can click on the different rows, which is really quite nice. And I can also make it into a data table by clicking the red triangle. So I can save it out as its own little data set if that's what I need to provide somebody. But we can do more than that. So I'm going to bring back the control panel, red triangle, show control panel. And let's imagine that not only do we want this broken out by genre, we want it separately for the different ratings. PG-13, PG-14, I guess it is now, et cetera, et cetera. So let's take rating. Let's imagine the table we want. I'm imagining one where I have a separate column for each of the different ratings. And so I'm going to drag it to the drop zone on top of N. And what Jump does is now spans the table out. Now we have different cells for each of the different ratings crossed with genre. So imagine I give this table to my colleague. They say that's all well and good. We'd actually like rating for inside of each genre. So we want actually a column that says rating. They want us to stack this, essentially. We could save it out and stack it, but we don't have to do that. Tabulation actually lets us just move this to the drop zone just to the left or just to the right. I guess there's the left and there's the right directions of genre. So the little drop zone there, that's a nesting drop zone. So now we've made a hierarchy. I can move it to the other side so you can see. Move it to the other side. There we go. Nope. Doesn't want to. Okay, I'll move that one to the other side. Wow, it's being really unwilling to do that for me. me undo. Right there. There we go. Weird. Oh, it's probably because it's the virtual join. It was probably taking it a second to go back through. Well, in any case, you can nest in whatever direction makes sense for your viewer. And oftentimes, this is not a question of what's right. It's just what is the way you want to look at the data. So within the G ratings, do you want these values closest together? So that sometimes is useful. Now, if you wanted actually a statistic to be calculated, maybe you don't care about how many movies have been rented or how many times these have been rented. You care about how much money you've made. So we actually have rental price per night and the number of nights it's been rented in each row. So if you look at that in the table, we have rental price and number of nights. We actually have to make a formula, which I'm going to do really quickly. We're going to come back and look at these later. I'm going to right-click, new formula column, combine, and take the product. Price times number of nights is how much money we made that night. So that's going to write me a formula column to the table. It's going to rip through 500,000 rows and calculate that. Now I have that column, I can use it. So that's the, where is it here? Rental price times nights. Oops, I've scrolled like crazy. And I'm going to drag that right in the center on top of n. So instead of using the number, I actually want to do some operation on that price. Now the simplest operation on data is a sum. We actually want the average, probably, unless we want to see how much we want or how much we've made in terms of money. I'm thinking we want the average amount we make for each of those. What tends to make us the most money? So musical is a bit less. Maybe we do want the sum, so I'll drag sum back on top of mean. Or maybe we want multiple. We want the sum, the mean, the n. I don't know why we would, the range. We could take multiple statistics, drop it right on top of sum, and it'll calculate all of them. So, and if we want to take one out, we can just drag it out. So it's a very interactive little table making tool. Always click done, that hides the control panel. And now this is just like before, interactive, it's selecting the rows in the table. All right, so that was tabulation. Tabulate's a great way to do it interactively. Sometimes you know exactly what you want, and you want to do it in a dialogue. So I want you to see table summary pretty quickly. Summary works just the same way, but it's a dialogue. So our grouping, remember, we had this as genre, and then we had a separate grouping underneath it, which was rating. We can move these back and forth, so if we wanted genre below rating or rating below genre, either way. In the first operation, I'm going to click Keep Dialog Open. In the first time we made this, we just had the count. So if I specify nothing else, just like in Tabulate, the first thing it gives me is a table of the number of rows. One important difference between this and Tabulate, the default thing this gives you is a table. It gives you a linked data table, in fact. But let's use that column we made, the number of price, and let's do sum this time. So I selected it, and I clicked sum, and this makes us that final table we just had at the end. So summary and tabulate, very similar in terms of what you can do with them. One gives you that interactive tabulation window that you can then make into a data table, whereas summary gives you the data table by default. All right, it's 1442. We actually got through that whole part. I am amazed. In 3 minutes, do we have questions on this section? We're going to have lots of time for questions, but anything I showed too quickly or anything you want to hear more about? Some of this going to be useful? That's good to hear. Yeah.
Yeah, I have a question about like the formulas and the average you just did.
Mm-hmm.
For example, if you have like a large database and some points are missing, like
Yeah.
if for example like for say with the movies,
Mm-hmm.
for some rentals you didn't write down the days that they were
Mm-hmm.
rented. If you calculate the average, for example, in Excel, there's a problem. Some data points are missing, and you need
Right.
to write it in your formula. Is it possible?
Yeah, you don't have to worry about that at all. So in summary and tabulate, it'll simply calculate the average based on the cells that are available and does it correctly. List-wise averages, as well. So I'll give you an example. Here's semiconductor capability. Let's say for some of these, you had some missing values. And let's say you were taking the average across column-wise. So if I do a new formula column, combine, take an average. The way it writes this function is what's called, it uses the mean function. And so if I look at it, by specifying it this way, list-wise, it's just going to, when it runs into a value that it's missing, ignore that and calculate this divided by 3 in this case. So it's smart enough to calculate it correctly. There are ways you can do this so that it'll spit out an error. So we have some situations where it would be really problematic if it missed a value and still calculated an average. So there's ways you can have it give an error. But by default, it'll just average without it. Does that get to your question? Mostly, yeah. Yeah. And we'll cover our formulas a little bit later too, a lot more. Yeah, these are very useful. All right. So why don't we take a break? 15 minutes, is that right? Back? Excellent. So we'll reconvene for quality. All right, so this second part, I was thinking I would spend most of the time talking about really data quality. Now you may get your data in already, you've had it restructured, you have the right columns in it, and you've even maybe aggregated or done some things to get it into a format that you need to share. But now your question is, do you have the right columns in the data set? That is, you have the right data you have, but do you have it in the right format? Do you need to calculate averages? Do you have to create or derive variables? Do you potentially have just plain out wrong values? So people have entered in codes wrong, machines have entered in things incorrectly, or maybe machines are entering things in a new way, so you need to recode. So those are wrong values. Do you potentially have outliers? I think most data, especially from machining or process, there's times you have data that's so far beyond what you expect that there's no way it's actual data. There's also times when your data is just so noisy that it's not a good representation of the actual underlying process. So we have to screen for outliers. And then lastly, there are times when you just are missing values. So things in the data table aren't there, and you try to assess why that is. And so there's some tools we'll look at here. So starting with deriving variables, I think this is probably the most common thing that gets people stuck after they first get the data in. And I find a lot of people will go back to Excel for this. So you have the data in JMP, you have everything you need almost, but you need to calculate some formula. So I've seen a lot of people export their data, go back to Excel, write a formula in a cell, fill down, and then take it back to JMP. And so what I want to talk about is just the ways you can do this so much more effectively in JMP and the reasons why you'd want to stay in the JMP environment for your formulas. And so I'm going to pull up in a data set. These are just serials. And actually, let me pull up I have one that's candy bars, which I think is more fun. Are some of these familiar? So things like Toblerone, obviously Crunch Bar, Hershey's. I just found out apparently Hershey's was made in the US for like the army, and they added wax so that it wouldn't melt. And I guess they just kept the wax in it. That's why it tastes so terrible. I guess that's the thing about Hershey's that I now know. So yeah, these are candy bars, and we have lots of data on the candy bars. And just to give you a way to orient yourself to the data set, I recommend you always do this. Whenever you get new data, go into Analyze Distribution, and let's just look at the data we have, because I think it's a nice way to get a sense of what data are in the table and what problems we might have. So the first is servings per package. We have ounces per package. We have a representation of calories. You can already see we have some really high calorie candies in here, so we can look at those later. Total fat, saturated fat, cholesterol, sodium, etc. So we have a lot of characteristics of these particular candy bars. And then we have some where the distributions are really far skewed. So vitamin A, for instance, some candy bars have it, some don't, and percent vitamin C, etc. Now, before I go on at all, how many of you like your histograms horizontal like this? Do most people? Probably the way JMP started was like this for you, right? Was that weird? It is for a lot of people. I will say, so in my background, I'm actually a cognitive scientist, and I can tell you that this is actually probably a better way to look at the data because you don't have to do basically a restructuring of the model. So up is higher on the dimension in the graph, like 6 is higher than 1. So it's actually less working load once you get good at reading them. But I didn't learn histograms this way. I learned them this way. So hopefully you all know that under the top red triangle is stack. Stack will rotate all your histograms and rotate all the output. So if you like looking at it this way, that's what you should do. Now, I guess it's not a data preparation thing, but this is almost like preparing JMP for yourself. You know under your preferences, for you on the Windows machine, it'll be under the File menu. Under Mac, it's under JMP. You can set a preference for anything in JMP for any platform you use. So if I go to Platforms and go to Distribution, you'll see I have Stack set there as a preference. I also have axis on the left. I also have the count axis turned on. So I've set a lot of preferences because I like looking at my data this way. And so if you're finding that you constantly change things whenever you open a platform, go and set it as a preference. There's no reason that you should have to always change things around. So it's partially data preparation, I suppose, because now your JMP output's going to look the way you want. So set your preferences. All right, so we have a number of columns, right? But we may have columns that we really need here that are missing. And so I want to talk about designing formulas in your table, and then ways that we can design them quickly if you have to make them all at once. So first, what do I mean by a column formula? So I'm going to go to the end of my table. I'm going to double click to make a blank column. I'm going to right click, and I'm going to go to formula. So the way, I should back up. How many people have used column formulas? Has anyone not ever used a column formula in JMP? Maybe a few. It's okay if you haven't. I often find people who have never had to design a formula just because they do it elsewhere. So the way formulas work in JMP is column-wide. So if I design a formula that is, let's say, calories divided by the number of ounces per package. So if I do this, I'm going to get a measure in this column of calories per ounce. Some of my things are high number of ounces, some are low. So maybe I want this value. If I do this, notice I didn't put any representation of what row or anything like that. I just design it for the whole column, and JMP will work sequentially through my columns to build this calculation. So in row 4 here, right, it's using the data from row 4 for that column, for each of those columns, I should say. This is subtly different than Excel, right? So in Excel, we would have gone to the top cell and done something like equals, and typed in a value and then filled it down. That's not how formulas work in JMP. The value, I think, is twofold. One, you can never misfill. The row here, row 2, only has access to row 2 data, so it's going to calculate this perfectly every time. And if we ever add new data to the table, so at the very bottom, if I add a value for, let's just do it here, ounces per package, let's say 5, calories, let's say there's 1,000, 5 and 1,000, it's going to calculate that as 200. Right, so JMP will actually continue to calculate this formula anywhere it sees those two values. Now I will mention, let me go back to the formula, a very common thing I hear from people coming from Excel is you need to reference a different row for some reason. Like you have, I don't know why it makes sense for these data, calories divided by the number of ounces for the package before, like the previous batch. Let's say there's some batch level and these are collected sequentially. So there are ways you can do that in the formula. And just so you see it under the rows function group, there's a function called lag. And lag here returns, by default, the previous value for that column. But you can return any value. So I could return the 5th previous value, 5 up from here. The default is 1. So this will now take, for every row, the first row can't be evaluated, right? Because there's no lag 1 for row 1. But for the second row, it says take the number of calories divided by the previous row's number of ounces. Kind of a weird thing to do here, but I think you'll get some value out of that at some point. So the formula editor is pretty easy to use. I can literally just click on things, wrap them in functions. So I can take calories. Maybe I want to do something statistical on it. I want to take the column mean for calories. You'll often see this where you have like a hard reference in Excel. You want to reference the absolute thing and never change the fill. So I can say the column mean for calories divided by the number of ounces. There's lots of things we can do here. But the general idea is that a formula in jump applies for the entire column. I'm just going to clear this formula out by selecting that outer box, and I'll click delete. Now before going to making these formulas quicker, I want you to get a sense of the kinds of functions a formula can use, because it's actually really powerful. A formula in jump, even though it can be simple, like one column plus another column, you can do very simple formulas, it actually can use all the power of Jump's scripting environment. So if we look at the functions, there's functions that apply to sort of row-based characteristics. That's where we found lag. Numeric functions like absolute value, take the ceiling, which is whatever the value is, take the value above it. The floor, if it's 4.7, it'll take it to be 4. You can integrate, you can take the mod, so the remainder, so lots of numeric functions. All the transcendental functions, exponentiation, natural logs, arcsines, those types of things. Trigonomic functions, I don't often see these, but people use sines and cosines. There's a wealth of character functions, so taking the leftmost 3 characters of a string, or the rightmost, or the middle 2, or trimming things out, or separating out words. There's actually really powerful character functions you can do in here. If anyone does anyone write regular expressions? Regex? Yeah, so Jump can handle regex. And you can do lots of really powerful string manipulation. There's a whole section here for conditionals and comparisons. So if you are needing to, you can write if statements. If the value in calories is greater than 100, in this new column, say something like, quote, high calorie. Otherwise, say low calorie, low calorie, low calorie. Right, so I can make an if statement. So I can say something conditional. And you can make these incredibly complicated. I could say else if, calories is less than, let me just do calories, is less than 50. Then I say low calorie, and otherwise middle, I don't know, whatever you want. There's better ways to write this kind of function, but just so you can see, you can use conditional statements. So conditional logic, you can have loops, and all sorts of probability functions. So densities, discrete probabilities, and lots of statistical operations. So the formula editor is incredibly powerful, but oftentimes we find ourselves writing kind of basic formulas. We need to take averages, we need to take sums, we need to have a bottle explode. So the formulas that we write most commonly, we can actually access using what are called instant formulas or temporary formulas. Instant formulas, or header formulas, are where you right-click the header in a graph, header in a table, go to new formula column, and you'll see that there are a number of these that are just kind of built in. I'll actually do one for sugars. We have a better distribution. Thanks, Martin. So I'll do new formula column. Now under transform, you'll see some of the familiar transformation options, not all of them that we saw before, but some typical ones. Maybe you want to round this value, actually round it, not just display fewer decimals, but actually round it. You want to exponentiate it, log it, take the logistic or the logit. Maybe you want to do something like standardize. Does anyone take z-scores for their columns often? So you take a column, subtract off the mean divided by the standard deviation. So that's a z-score. So you can just say standardize, and Jump will just standardize that column. Or one I see a lot, people want to make a column 0 to 1. So a 0 to 1 function gives the lowest value a 0, the highest value a 1, and then it just linearly between the two. So I can even take a set of columns, go to distributional, and say range them 0 to 1. And now it'll write me those range columns. So you can do lots of pretty straightforward functions just by right-clicking and doing new formula. Okay, so if we take 2 columns, let me take sodium and carbohydrates. I can right-click, and you'll notice now I have a new option called combine. And so combine will, using those 2 columns, do something. I can take the sum, 1 plus the other, difference, 1 minus the other, reverse order difference, the second minus the first, not the first minus the second. Take the product, take the ratio, the reverse order ratio, second divided by the first, min, max, average, standard deviation. So a lot of common combination functions. So new formula column is a really useful way to access those types of functions you do often. So I'll just write one really quickly here. I'll do combine. Actually, let's do the one that we did before. Let me go to calories, which was here, and I had ounces per package. Right-click, new formula column, combine, and I'm going to do the ratio reverse order because I want calories, the second column in the selection, divided by the first. And so that writes me calories divided by ounces per package. And if you look at the formula, maybe not surprisingly, it's just written it out. It hasn't actually computed it for the column as a set value. It's just written a formula that will continue to recalculate. All right, so let's imagine you're already into making a graph. You know, you've set up lots of things. You already have the brand. You know it's going to be a means plot. You already have sodium in there. Maybe you have carbohydrates in there. So you're already pretty far along, and you now want that calories per ounce, and you don't have it in the table because I actually already deleted it. When you're in a launch window or in a graph, you have access to the columns list, and that actually operates the same way. So I have ounces per package and calories there. I can right-click here, go to combine, and do the ratio reverse order. So without leaving where I am, I can actually make this column, and I want you to notice it's italicized. That's because it's actually using it as a what's called a transform column or a temporary column. I could use it. I'll add it to my graph here. But if we look in the data table, it's nowhere to be found. The way it's working, if we want to poke around the underlying scripting language, the way it works is to use something called the transform column. So in its script, sort of under the hood, it says, well, the column doesn't exist in the table, but here's how you make it. It's a formula, calories divided by ounces divided by package. Now, if you know you're going to use that column repeatedly, you can just right-click it and click Add to Data Table. And what that will do is actually properly add it to our data table right there, calories divided by ounce divided by package. So you can make a column from anywhere, you can add it to the table if you want, or you can use it just that one time in a graph. Just the one time is what we commonly see if somebody is trying out different transformations. So you're looking at the effect of, I don't know, sodium and the relationship with sugars, or vitamin A, or something where you see some crazy distribution, you say, okay, maybe I really want the log of vitamin A. So you do a transform log, and you replace that. You're like, oh, okay, that looks better. It doesn't really look like anything, but maybe that's going to be helpful for you. So trying out transformations is a nice way of doing that. All right, so that's column formulas, instant formulas, and temporary formulas. Temporary are the ones that you make in a platform launch window. Any platform launch window. So I can take calories here and transform that even. So you make it in the launch window. It exists for then, but doesn't exist back in the table till you add it. And then instant formulas are the ones right at the top. You can right-click. And I will say, the character operations are really useful. If you right-click two columns, you'll notice the character combining options. I can concatenate. I can title case them, take the first word. First word and last word tend to be really useful. There are sometimes you have like a part number. So it's like part number space batch number is the column. And you just want the part number. So you just right-click that character column and say take the first word. So it pulls off just the part number. So those are the three types of column formulas generally. All right, so how many of you have ever had a situation where you have something numeric, let's say calories, and for the analysis, you really don't want to treat it as continuous. You would rather have maybe, let's say 50 calorie bins, 0 to 50, 50 to 100, 100 to 150. You actually want to treat those categorically. Has that ever happened? You want to bin a numeric variable? So we could do it as you saw with if statements. Be kind of tedious. There is an option under the columns menu, utilities, and it's called make binning formula. And binning formula, I'll warn you, this plot is going to look a little bit crazy. What it's done for us is it's showing sort of just jittered where all the points are in our data set. And by default, it's going to choose a default width and what's called the default offset. Offset is where the first bin starts. Width is how wide are the bins. And I'll actually set the bin width to 100, let's say, and the offset is usually the first value in the table. But just so I don't have crazy bins, I'm going to set that first offset to 100. So now I'll have 100 to 200, 200 to 300, 300 to 400, 400 to 500. When I click Make Formula column, notice what jump built me is this calories binned option. And actually, let's look at that together with calories. So I'll do calories binned, and I'll do calories, I'll do histograms only. Let's just look at how jump built these. And so the 200 to 300 literally are the 200 to 300 observations, 100 to 200 of those. So maybe that's how you wanted to split your data up. Yeah.
Is it planned to integrate this interactive binning add-in to the jump?
That's a great question.
This is, I think, more convenient and better to use than this. I never used this. I always use interactive binning.
100% agree. And we can't technically share what's being developed for Jump 16, but I wouldn't be surprised if Make Binning Formula got an improvement. Because I agree. And what he's referring to is a really great add-in, and you can find it on the Jump user community, which is called the Interactive Binning add-in. And my colleague Brady, his name is actually Brady. He has the same first and last name. Because his parents have a sense of humor? I don't know. There actually is one other person on Jump with the same first and last name. It's Rajneesh, because when he immigrated, they asked him what his last name was. He said, I don't have one. And they said, you have to pick one. He says, okay, it's Rajneesh. So they said Rajneesh. Anyway, little facts you now have about Jump. But Interactive Binning by Brady does just a separate idea of binning, but I think it does it a little bit better, which is why we all agree it should be a part of Jump. So let's look at how that would look for calories. Actually, before I do that, just so you know, add-ins in Jump are very easy to install. If you've never installed one, don't hesitate. Just go to the community page where it lives. You'll click on the Jump add-in at the top. It'll download. They're always pretty small. You just open it up, and Jump says, hey, do you want to install this? You click Install, and that's about all you have to do. What'll happen if you've never installed an add-in before is a new menu will pop up called Add-ins. I may have installed an add-in or two. So you'll see mine. I'll find Interactive Binning. Now what Interactive Binning will do, which is really, really nice, is that it gives you the ability to set cut points based on things other than fixed width bins. So I'll designate cut point for calories. It's going to show us the histogram. And you can do a number of things. You can design your own cut points if you like, but I'm just going to say cut at percentiles. And let's say I want this at the 25th percentile. So it'll be 0 to 25th, 25th to 50, 50th to 75th, 75th to 100. So I want essentially 4 bins as equal width as possible. Instead of having those really small ones, I want 4 kind of equal width bins. These are interactive, so if I want to dial these around and change it up a little bit, maybe that's what I want to do. Once you've found where your bins are, you go to the red triangle, save a group column. Just like before, this is going to write a group column to your table. Let's actually look at how all 3 worked, because I had 4 bins, whether I used the binning formula or the grouping. But this time, if we look at this is where actually I'll unstack so we can see them a little more clearly. So for the calorie groups, interactive binning, they're all pretty much equal sizes. And if you notice, the high bin includes things from the second, third, and fourth bin of that binning formula, because it's taking, which is really long tail, and binning them all together. And so I find the interactive binning a lot more useful usually, but sometimes just the straight binning formula is useful. So you're seeing how it works. These also are written with formulas. So if you look at the formula for this, this is written with that, basically a series of if statements. If this, then this, if this, then this, if this, then this. So it can be edited if you like. So again, to find that, just search interactive binning, Jump. It'll find you really quickly to the community. Has anyone downloaded an add-in before? Just a few of you, okay. Does anyone set preferences in Jump? Probably a number of you. Has anyone ever moved computers and been frustrated that they couldn't get their preferences to move with them? Maybe. So just if you do run into this, search Jump Preference Manager. And I hate to talk my own things, but this is one I put together, which I think is just really useful. You can set up preference sets and export preferences. So if you have a group that you support and they all use jump and you want them to have the same preferences as you can set your jump up and then export a preference file. So preferences manager, it's something you can get as well. Okay. So those are all the formulas. Any questions on that? Yeah.
Is it possible to have a different formula for one cell in a column?
You can. So can you tell me a little bit about why you'd want that?
We have like data
Mhm.
which they're like pools. Some are
Mm.
pools, some are not, and they have you calculate like the concentration.
Yeah.
You use different columns.
Gotcha. So you may have something where maybe there's even a variable that defines what type of formula
Yeah.
each cell gets. Yeah, so it wouldn't just be each row. It's like you would look up something, and then you could say, do this formula if this equals.
Yeah.
Let me give you a couple examples. So the most typical way we see this is you have something like, in this case, we have a bunch of different brands of candy bars. Maybe each brand requires its own calculation. So I put brand in here. I would go to conditional, and I would select something called a match function. And what match will ask you, with brand already in there, it says, do you want to add arguments? What that means is, do I want to look up the brand column and get all the values? So now it says, okay, if brand is equal to Adams and Brooks, then do some function, which maybe is calories divided by ounce. Then for Annabelle, we want, I don't know, ounces divided by calories. Who knows why? Bit of honey, that's cholesterol divided by sodium. So now for every different name of brand, we can have a separate function. If you really, really need it separately for each row, I would do a match function, and the expression is row. What row number is it? And so you can say for row 1, do calories divided by ounces. And then the trick is to get to another value, you just hit the comma key. You can just use it a bunch of times, so you can get a bunch of arguments. So you can say for row 2, do something else. It's really uncommon. You have to do something that's this granular. It's probably a better way to format the data if you have to do this. But just so you know, the match is really powerful because essentially it gives you the option to contextualize your formulas.
Yeah, that works.
That works, yeah. And the trick is, just so you all see it again, to get match to pull the arguments from the column, put something in there first, like brand, then click match. And it'll prompt you magically, do you want to add the match arguments from data? The reason that's valuable is it saves me from writing all of those in there, which just seems like a waste of time, right? Yeah. Yeah, good question. All right, so that was formulas. Useful? You're all going to use formulas? Great. So there are times where you have the data you need, you have the derived variables you need, but you have values that are wrong. And this can come about from a lot of reasons. And I'll go back to that restaurant tips file, and like I said before, let's use distribution, because I think it's a great way to first give your data a screen. So I'm going to open distribution, put all the columns in, and I kind of like to check histograms only. It's a nice way to very quickly look. And if we're just looking down each distribution, bill amount looks okay, tip amount looks okay, but we already see there's a problem with the categories of credit card. We have some no's and some n's, and some yeses and some y's. So maybe different people entered these data and we concatenated them. These things happen. Number of guests is numeric, that looks okay. Day of week's a whole mess. We have Fridays, lowercase and uppercase. We have Wednesdays with lowercase. We're fully spelled out. Somebody typed in Wednesday, right? So maybe different people have been entering these data, or it's just how they write them on their receipts. And then finally, server is also all over the place. We have uppercase and lowercase. And some people have actually written out server A, B. One person wrote out server capital B, right? So everyone found a new and different way to be wrong. Okay, so we need to fix these values because as you can see from distribution, JUMP will treat each unique level of a categorical factor as a unique level. It doesn't know that C is the same as C, is the same as server C. So we need to recode. Now, I'll tell you, in Excel, the typical way is something like find and replace, or maybe an if statement, but often find and replace is really useful. I will say in jump, find and replace is actually really, really powerful too. I don't overlook it. Some problems are best served with a find and replace. You can, again, put in find what and what do you want to replace it with. Find and replace also supports regular expressions. So you can match a pattern and replace something else with it. And you can restrict it to rows. You can search column names. It is a very powerful tool. But I want to talk right now about recode, which is probably my go-to for fixing these values. Let's start with credit card. Right-click, recode. Now, recode has a number of different ways you can operate with it, but let me just orient you to what we're really looking at first. We have a count of the number of levels of the variable we selected. So 99 times we saw an N, 7 times a no, 45 a Y, 6 a yes. Already gives us a sense of what probably the correct value should be. We have a listing of the old values, so N's and no's, Y's and yeses. And then we have a section where we can type in the new value. So there's a number of ways we can fix this. I can type in the yes and take out the E and the S. And notice what jump does is it knows it's merging a group. It says, oh, I'm merging yeses to the Y. So I could do it that way. Let me undo that. I'll click undo. Another thing, oh, Ghost getting coffee again. Another thing we can do is select the Y's and yeses and click the group button. That also creates a group merging the Y's and yeses. Or we can grab them and right click. And this I actually think is the best way because this gives you a lot of options. We can group to Y. The dominant category comes first, group to Y. Group to yes. We can just select those rows in the table, which sometimes is nice because then we can go in and use that data view and kind of say, oh, what should the correct values be? Maybe there's something about those columns we need to look at. Let me close that linked subset here. So we can right-click and get the selected rows. We can actually make those selected rows into a table if we need to, or we can copy the rows or the tables. Sorry, the column rows or the table rows. Usually what I'm doing is I'm just grabbing them and grouping them to a value. So I'll group that to Y, right-click, group that to N, and now we've actually done our recoding. It hasn't applied to our table yet because we have to decide what type of recoding do we want to do. Do we want to write these values to a new column? Like literally write the values themselves. Do we want to write a formula to the column that recalculates every time new data is added? Sometimes useful. Or do we want to write over the data that's in the data table? I really, really rarely suggest that this is valuable unless your recodings are so obvious that there's no way you could have been wrong. So I'm going to do it here, but I still don't think it's the best because you can't go backwards. Of course you can undo, but once you save the table, no one can see a month from now what your original values were. But so you see it, I'm going to click recode. And what jump has done now is that column actually has no's and yeses. So it's collapsed the values, and now we're looking at just 2 values. Okay, let's tackle day of week, because that was a little bit more annoying. We had a bunch of values where people had done capitalization and different spacings. I want you to see that under the red triangle, there are a lot of options that can help us with things like this. We could convert everything to title case, which already collapses some of the categories. We could remove white space, which actually does pretty well, collapses the categories. And if we wanted to, we could fix that last one just by grouping Wednesday to Wed. And actually, we're pretty much done. But let me undo all of that, because we can also let jump just try on its own. There's this option to group similar values, which is pretty neat, because what this is going to do is it'll give us the option to do all the things we just did, ignoring the case, white space, punctuation, but magically it can make character edits. So what if somebody misspelled Wednesday, as I used to always, because it's actually really hard, Wednesday, I always had to say. So if somebody had misspelled it, this will allow it to change characters to make one string into another string. And the way this works is it takes whatever the shorter string length is, I'm telling it it's allowed to change a quarter of the number of characters. So if we had a string that was 20 characters long and one that was 10, jump would be allowed to change, well, 2.5. So it'd round down to 2 of the characters of the shorter string or the longer string to make them the same. So it's an edit distance. When I click OK, you see jump does pretty well. It finds all the things that we found before. in Miss Wednesday, because that's just too different, right? The shorter string is WED. It can barely change a letter to make it the same, so I have to group those myself. Okay, so now that I've done that, let me not do new column, let's do formula column. So you see what that looks like. So it's going to write a new column to the table. It's going to use a formula using some of Match's or Jump's own internal recode logic. Essentially, map value as previous value, new value, previous value, new value, previous value, new value. It has a function for what it's recoding. But what's magical is, somebody now types in the bottom, lowercase WED, and because Jump knows how to fix it, it's now making that capital WED. So unless somebody comes up with a brand new wrong way, it's going to be able to recode. Yeah. People always come up with brand new wrong ways. The ingenuity of humanity, right? To be wrong in new ways. Okay, so that's recoding with a formula column. And let's look at one more option under server. I'm going to go to recode. This one we could try to group similar values, but notice with a bunch of those one character strings, it's going to do what? It's going to say, oh, well, A, B, C, A, B, and C. I can change one letter and make those all the same. That's clearly wrong, right? And it made server A, B, uppercase B, C the same. So sometimes group similar values is not what you want to do. So in this case, this is where I would say probably just convert everything to title case. That'll fix most things. And in fact, I just have to grab the A's, group them, and grab the B's, group them, and then my C's. So a little bit of work, but not that much work. But this time I want to show you one final option. Under that red triangle, under script, we can save out this recoding actually to a script that we can run on this table or other tables. And the reason why this is useful is, let's say you have 10 different tables that need this recoding. Instead of just doing it this one time, we can save this out to a script, run it, I just hit the run, and it makes that server 2 column. Right, so we could move this now, open up a different table, run it again, or maybe this is just a recoding that we always have to do because every week somebody sends us the same table with the wrong thing. Maybe not because of human error, maybe the machine that writes this out for some reason writes out different values in different ways. Who knows? But saving a script is actually a really nice way to have that stored, and then you can rerun it later. All right, wrong values. Any questions on what I showed with recode so far? Cool. Now there's a number of things in Jump 15 we won't go into now that recode added. I just want you to be aware that they're there. So replace string was added in 15. Or actually, no, I think it was added in 14. But this lets you essentially do a find and replace within recode itself. And so if there's some string in here you need to replace, actually I'll do it, let me do it with server. So if I do server here, recode, if I just wanted to strip out server, the text server, I could do replace string, server, and I could just, it's already done it. So server, you'll see the current value and the new value, and hit OK. So it'll actually pull that string out, because maybe that's getting in the way of the recoding. So that is one nice thing that was added. The biggest advancements were under the advanced section, though. So under advanced, probably the biggest that's cool is apply a mapping from a table. And what this does, which I think is really neat, is let's say you have a very complicated process where, I don't know, you have hundreds and hundreds of batch numbers, and you need to recode them to some new system. So you have an old system that had your previous batch identifiers, and you have a new system and their identities. You have something that links the two. You could pass the table to Jump. You just say choose table, and you say, oh, previous batch number should equal new batch number. And Jump can apply those recodings from that table, which ends up being a really, really useful way to take an old value and make it a new value. I'll give you another example. Sometimes you have a table where all your rows have data that are in one language, and you have the translations in another table. You know, this value should equal this in this other language. So you can apply that translation by choosing a table and doing the match. So apply a mapping from table is really useful. And there's some other really, really powerful things. I think we'll have a webinar later this year, maybe early next year, just on recode. because the advancements here are pretty substantial. But extracting segments, you could do lots of really powerful things. So we won't have to go into that here. But the basic use of recode is just to take a previous value, make it a new value, make a formula column, or save it as a script. All right. Any questions on recode? Okay, extreme values. Now let me go back to, I'll use the serial data set for this one. And again, just so we get a sense of the distributions, I'll grab just every column again, stick it into Y, stick OK. I will mention in jump 15, the histograms at the top of your table can serve kind of the same purpose. You just click it, you can scroll across and get a sense of the distribution of all your variables. I think that's great. They're also interactive, very powerful. I still prefer to go into the distribution platform so I can look at all my variables. I just think I'm used to seeing it this way, and I can get a better sense of the data. When I'm doing a first screening for extreme values, though, I wouldn't check histograms only, because one thing you get, oops, let me go back, distribution, recall. I wouldn't check histograms only, because I kind of like, for especially columns that are numeric, the first sense of whether a point is outlying are these sort of the outlier box plot. And is anyone familiar with this calculation, the outlier box plot? It's 1.5 times the inner quartile range. So the inner quartile range is the box here from one end to the edge. So that's the inner quartile range, the distance from the 25th percentile to the 75th percentile. 1.5 times that is the outer fence. And points that are beyond the outer fence, at least by Tukey's standards, were outlying enough to warrant suspicion. And I'll make a point here, the idea of detecting outliers, this gets into a really heated as statistical arguments can get among statisticians, what counts as an outlier and whether you should remove outliers. There's good arguments on all sides that I've heard. So we're not going to really weigh in, or I'm not going to weigh in on the best practice for outlier removal. I think that comes down to a substantive knowledge of your area and the purpose of your modeling. But we can at least say what constitutes something that's pretty far to deserve scrutiny. And so I think that's our job here for this section, to identify points that deserve extra scrutiny. And as a first glance, the points that are beyond the outer fence, those deserve some extra scrutiny. If they're a part of a distribution that's highly skewed, right, has this tail, you're going to often get points that are that far away. Tukey's outlier range test was really about normally distributed distributions. Still, those points are pretty far away, so we may wish to think about those. So one nice thing about distribution is you immediately get that sense of points that are far out. And so one really nice feature of distribution, and actually a really nice feature of all platforms where you can see the points, and actually any platform where you can select the data, is when you right-click, you get a pretty consistent rows menu. And one of the options under the rows menu is row hide and exclude. So from this distribution, let's say I just knew those were too far out to be considered a part of the distribution, and I needed to exclude them. If I right-click and hide and exclude there, that's going to apply a row state to the table. Remember those row states where you right-click and exclude? It's actually applying that to the table. So now any new analysis won't include those points. So that's one thing we can do. Let me bring it back for a second. I'll actually show you my favorite workflow, which isn't to just right-click and exclude them, because I think I like to mark them for being warranting of more suspicion, not just getting rid of them. There's this option called name selection in column. Has anyone used this before? So this is one of my favorites. Name selection in column will pop open a dialog, and it says, okay, you have a selection. You want a new column that identifies these points. What should that column be called? And I'll say this is high fat. And it asks you, what do you want the selected column or the selected rows to have? I'll give it a 1. And if the rows are not selected, a 0. And you'll see what this is going to do. Those rows I have selected now in the table, there's this high fat column. Everything that was unselected has a 0. Everything that was selected has a 1. And so let's say later on I really want to exclude those data points that were high fat. I can do one of two things. I can right-click the one, do select matching. Remember that one? And I can right-click and exclude. That's one way to do it. I can use the data filter. Remember that? Go to data filter, put in high fat, and I could do a 0 or a 1 and only include the ones that were not excluded or not given a 1. So lots of options there. But by having a column, I have a selector that I can use. Now this actually benefits me in a number of ways. What if I go through my data, I see fiber, there's some high fiber cereals. So I'll name that selection, I'll call it high fiber, and give it a 1 or a 0. And then I have this calories from fat. I can right click. And by the way, these may be the same rows as the others. It doesn't really matter. I'm just making separate selection columns. So I'll name that selection. And so this is high cal from fat, 1 or a 0. Now, we're familiar with making column formulas. So let's say you wanted to have a single selection. Did any of these rows meet one of those exclusions, that they landed them in the high category? Remember right-click, new formula, combine? I could take a maximum, which says basically across row-wise, is there any one in this row? And I can essentially say now use that as my selection. That'll select anything where it was high from some classification. And I can exclude or do whatever you think is justifiable based on your data. All right, so name, selection, and column, not to be overlooked. It's useful for lots of things. Maybe you just want to grab the low values and name a selection. Or this is often where I see it, you're in a graph and you see some clump of data. Let's find somewhere where there's some clump. That's a nothing graph. So maybe there's this block up here and you want to investigate them further. So you can right click there, go to rows, and name, selection, and column is always there. So anytime you can get to the rows menu, which is pretty much anytime you can click on a point, you can get there and name a selection. So a really, really useful tool. All right, so far what we've really been looking at are univariate ways of looking at extremeness. And by univariate, I mean one variable at a time. Yes, we looked across multiple variables and we made separate selection sets, but we were essentially looking at whether a point is outlying with respect to its own distribution. So with respect to calories, with respect to fat, that kind of thing. And we looked at using distribution with excluding data, with naming a selection. What we didn't look at was using a coloring. And this is actually very, very nice. You can grab points that are high, and you could always right-click and give them a color. So I can color those rows something special like red. Or I can give them a special marker. So I can give them a star. And so now when I go into a graph and look at calories by protein, the stars are the ones that I identified. So markers and colors, those are all really useful, but they're, in the end, univariate. They're looking at a variable with respect to just its own distribution. So I want to talk about two different ways that are a little bit beyond a univariate approach, which is multivariate and then model-based, outlining this. So first, multivariate. Let's look at a platform which is really fantastic under multivariate methods, multivariate. Has anyone used this one? A few, maybe? So multivariates, I would say, is the generalization of the distribution platform. Distribution is about looking at each variable separately and its distribution. The multivariate platform is about looking at the variables in multivariate space. So just to give you a sense, let me start with fewer than 11 variables. Let's do 3. I'll do calories, protein, and fat. And I hit OK. Multivariate starts off with a correlation and a scatterplot matrix. So the correlations are, if you look at the intersection, the correlation between calories and protein, 70%, or 0.7, sorry, about 49% of the variance. Between calories and fat are 0.64. You'll notice that there's a mirror. So protein and calories here is the same as calories and protein here. It's the same thing. Multivariate relationships like this, there's no direction. One's not a predictor and one's not a response. We're just looking at what their correlations are, the structure. Now we also get a scatterplot matrix. So this is, if you haven't seen one before, it's the plot of the variable listed here, so calories, protein, or fat, against the other. So calories versus protein, this is calories on the y and protein on the x. Down here is protein on the y, because protein's here, and calories on the x. So they're mirrors of each other, but they're the same data. So we can look at the multivariate structure here. We're looking at it in bivariate space because we're seeing each pair of variables together. But the multivariate platform is principally about looking at it in multivariate space. So we can go up to 3. Beyond 3, it gets a little bit hard to generalize, but there's a 3D representation of this. So our 3D scatter plot. If you ever have somebody coming by, you want them to think you're doing advanced work, just set this spinning and just leave it on the corner of your desk. And then they'll, just be really impressed with you. The trick to get it spinning, by the way, is hold the shift key and then give it a little click and a drag, and that'll just leave it rotating. It works especially well if you just tuck it behind a window. So it's like nonchalant, right? It's like you don't even care that it's over there spinning. You're just hanging out. So anyway, just my tip to you. So backing up though, so if we're wondering about multivariate outlyingness, what I'm prompting with this section is to think about where does a point live with respect to all the variables in the space. And so if I start with more variables, I think I already have one open. Nope, let me start with more. So let's do one with 5 variables. I'll pick the top 5, calories, protein, fat, sodium, and fiber. So there are some points in here that are in, I should say, unexpected places. Because if we look in the bivariate relationships, there's places where we would expect to see points. So let's look at the bottom here. I'll even move this window up so we can see it. So this is calories versus fiber. So there's kind of a coherent slope here, right? More calories, more fiber. But then there's some weird ones that are kind of unexpected based on the other pattern. The pattern of data is to be low calories, low fiber, and then high calories, high fiber. This is kind of positive. But these are low calories, really high fiber. Not surprisingly, that's all bran with extra fiber. So the data aren't lying to us. So that's unexpected in 2 dimensions. Those are strange points with respect to the distribution in 2 dimensions. What if we could ask the question, where are the points that are strange with respect to 5 dimensions? 5 dimensions we can't really visualize. We're not built for it. But we can generalize that idea of 2-dimensional distance, Euclidean distance, and we can dimensionalize it in 5. And it's called a Mahalanobis. And that's available under the red triangle, outlier analysis, and Mahalanobis distance. And the way this works, if you imagine that 3D scatter plot again, let's pull open the ellipsoid. So if you imagine this ellipsoid, there's a point that's kind of extreme right there. And the general trajectory of the data is along that ellipsoid. That's sort of the 95% ellipsoid. But there are points that are in odd places in 3 dimensions. And if you think about how we would make a distance measure, we want a single value for how weird that point is. Well, we can say how far is it to the center. That's called the centroid, or the multivariate mean. We can say, okay, first, how far is it to the center? And then we can kind of scale that value by how off-axis it is. How far from here is it? Because there may be a point dead center here that's just as far, but it's kind of within the trajectory. So we're going to scale it by how far outside of the trajectory it is. So if we do that, we get what's called a Mahalanobis distance. And the way this plot works is it's the row number on the x-axis. This is literally the first row in the table, and this is the last row in the table. And the y-axis is that scaled, covariant scaled distance score. How far is this point in 5-dimensional space to the multivariate centroid, scaled by the correlations, or scaled by the covariant structure? So let me select this point. I'll even give it a marker. Let's give it a star, because that's the weirdest point in our data set by this measure. And let's look at why it's weird. So if we look at the scatter plot matrix here, in almost every scatter plot, it's sort of, well, not all of them. In calories and protein, it's kind of where you would expect it. But in protein and fat, it's sort of off to the side. In calories and fat, it's kind of off to the side. In sodium and calories, there's not that good of a relationship there, but it is still weird. It's really low sodium, but high calories. Right, so it's sort of in weird places. It's a weird point. And I want to show you another way to look at this. Well, I should say, in this plot, anything that's above this control limit, or the control line, those are points that are kind of more different from the multivariate centroid and the pattern than we would expect. assuming all these variables are multivariate normal. If you imagine a normal distribution, that's a normal distribution in 5 dimensions. So if we had that, these points are really strange. Again, warranting of suspicion. So don't just throw them out. You could right-click and exclude, but I wouldn't. Warranting of suspicion. But I want to show you a plot. Oh, yeah.
So can we actually test for normal distribution first to see if this actually fits, or is it okay to use this type
Oh,
of
it's okay still. I would just not take seriously the control line. Yeah, that's all. Yeah, and testing for multivariate normality gets even more dicey than regular normality tests. But I think it's a good question. If you want to use that as a control limit, then you have to first satisfy your univariate distributions are normal. That's a really good question. But let's just, without using the control line, just knowing that we have one point that's really extreme, I want to give you a visual that helps you think about why that point is strange. And so if we, using Graph Builder, I'm going to grab the first 5 columns that we used before, and I'm going to turn on something called a parallel coordinates plot. And the way this works, let me actually just make the lines a little bit thicker for you to see. All right, so a parallel coordinate plot is showing us in 5 dimensions right now, each serial. So let's grab one of the most common, the ones down here. Let me actually just grab just one of them. So let me see if I can grab just one line. There we go. So that one, that's wheat checks. And so if we look at just wheat checks, so where is wheat checks here? Wheat checks. There's the line for just wheat checks. I'm using a local data filter on name. Nice way. So this is the profile of wheat checks. It's middle of the bunch in calories, maybe on the higher side, about 180. So that's the dimension of calories. Middle of the pack on protein, maybe a little towards the higher side. It's really low on fat. It's really high on sodium, and kind of middle-low fiber. Right, so every line in this plot is the profile. There's one that's really low calories, low protein, low fat, medium sodium, low fiber. Right, every one of those is the profile. And then if you look at all of them, that's the overall profiles of every cereal in there. So what about the extremely weird one? So there it is. And so the extreme weird one was 100% Notes brand oats and honey. So let's find that one. Oats and honey. And nuts. There it is. So really high calories, protein, really high fat, and almost no sodium and no fiber. And so a different profile than really all the rest. And probably what it is that these things share relationships that we would expect to see for that particular cereal that aren't there. And so it gives us a nice little way of sort of exploring outlyingness. Well, this gives us a nice way of visualizing it, but Mahalanobis distance is a nice way of just giving us a numeric measure of how distant things are in this multivariate space. So another way you can look at outlyingness, and a way that we'll see JMP uses in one of its automated tools. But I wanted you to have a sense of what it looked like from that sense. Okay, before we do more on that, I want to show you a model-based method, and then we're going to look at the way that JMP can do this in a more automated sense. All right, so let's say we run an analysis. We have complex carbohydrates by sodium. And I've just done a simple linear regression, right, fitting a line. Now, you can already see there are points here that are really unexpected given where that line of fit is. Right, so they are low on sodium completely, but really high on complex carbohydrates. And if you were to exclude these, so row hide and exclude, and then allow this to recalculate, so I'll go to redo and select automatic recalc, it's going to actually, well, I'll just actually redo it so we have it in a separate window. Let me do that, redo analysis. There we go. It's going to have a very different line of fit. All right, so those points are exerting a lot of influence on the coefficients of the model. That makes sense? So the slope is very different, and so is the intercept. So there's a measure within fit model, and I'll just set this up for you again. I just did analyze, fit model. I did complex carbohydrates, fitted by sodium. I assume a lot of people use fit model. So once you get this, there's an option under save columns, which is the Cook's D influence. And this is a really great measure of model-based influence. This is essentially an aggregate measure of how much that row in the table is influencing the model parameters. And so let me save this. Oh, actually, let me unhide all those points I just hid. So let me select those. I'll just clear the row states. Oops, I got two of them. So Cook's distance. So I want to keep those points in because I want you to see how high their Cook's distance is. So I'll save Cook's D. And since this is a row by row measure, it's going to give it to us in the table. And one thing I can do, I can sort this table, or I can just look at it in distribution. This is a nice way of looking at the Cook's distances. So the general cutoff is a Cook's distance above 0.1 is pretty extreme. It's influencing the model parameters a lot. And if we find those values that are influencing the model the most, they're the ones we expected, the ones that were in the really unexpected place. And so this is one way, if you have even a very complicated model, and it could be multivariate, it could be with, curvature, all sorts of things. It's a good idea to look at what points are dramatically changing your parameters, especially if you care about the parameters from your model. Because if you have a few points, in this case out of 76, there's 5 points, where if I removed them, it massively changes the slope of the line. And that's dangerous. Dangerous in the sense that if those are miscalibrations or if those are things that were entered wrong, if 5 points can massively change your analysis, then that's something to really look into. And so Cook's D, I think, is one of the more useful measures of outlining this. But it's based around a model. So fitting a model first, seeing what the coefficients are, and then seeing what the points would change. So I think really, really important. Okay, so now you can see a number of different ways you could do this. I want to show you a great tool in JUMP when you have thousands and thousands of variables. I'll actually go to a different data set. I'll just use the process semiconductor data set I was showing before, where I had those 128 processes. And under the Analyze menu, under Screening, there's an Explore Outliers section, which I find to be really, really useful, because what Explore Outliers will do is you can pass it all of your variables, hit OK, then choose the way you want it to screen for outliers. In a univariate sense, we looked at those 2 key range outliers, the 1.5 times the interquartile range plus the third quartile. That's what this one is. If you do quartile range outliers, it can screen the data and find outliers based on what tail quantile you want. So I'll just make it a little simpler here, rescan. Actually, let me do this as 0.3. So 30% of the tail, just so you can see if it finds an outlier. It found outliers in one column and a second column, in that column there. You can do lots of things. You can add missing value codes for those outliers. Maybe they're all 99999s. Sometimes that happens. Sometimes you just want to select the rows that are outliers, and that's where you can use the data view. That's actually probably my favorite. Don't exclude them, figure them out. If you really want to exclude, you can just exclude them right there, and that'll exclude them in the data table. Yeah.
Can you exclude just the cells instead of rows? Because when you have like different processes,
I know, yeah.
One cell,
There is no cell-wide exclusion. So what I would do, I would select the rows, and then I would do rows, name selection, and column. Where row selection, here we go, name selection and column. So then I would say this is exclusion for, whatever that particular variable is. So then you can exclude differentially based on the analysis. So if sometimes you're not using that exclusion, you can not use it. But yeah, this has been a request actually for a while. Wouldn't it be cool if you could right-click a cell and exclude that cell? Yeah. Yeah, we have the request in. It's a very complicated thing. Yeah?
Can they just do the right triangle for columns of the processes with 128?
Yes.
How did you create that?
Oh, that's a great question. Yeah, so in JUMP 12, they added the ability to have column groups. So you have this whole list of columns, and doesn't that suck? You have this long table. So right-click, group columns. Yep. You can also do it with scripts. grab them up there, right-click, group the scripts. So sometimes you have, actually I think the columns were 11, the scripts were 12 in jump, yeah. And by the way, you could just ungroup them by ungroup. Yeah. So quantile range, we're much like the univariate outliers. Let's go back to commands. Robust fit is a slightly different idea. It's fitting a penalty function, either a Huber or a Cauchy. It's basically a function on how to weight the extreme values in the distribution. And then what it can do is say, okay, once we have a robust mean, a mean that is uninfluenced by the extreme values, how far are points from that robust mean? So just like before, you can scan the columns and find those points that have outliers and exclude them, color them. You can color the cells. Multivariate robust. This is going to take a long time with these data. Let's just see if it works. So what it's going to go through, oh, crap, this is actually going to take a long time maybe. So this is now trying to fit 128 dimension multivariate normal. And then it's going to see, just like we did before, those Mahalanobis distances. So it's going to try to do that. We'll see how long it takes. I'll just keep talking through it. Just like before, once it does that, you'll select and you can hide, exclude, etc. And then there's one really interesting one which we didn't talk about, the multivariate. I'll just cancel that. So again, gives them a Mahalanobis distance, very similar to like what we saw before. But now this is, stretch your mind around this, 128 dimensions, and it's trying to fit the distances. And then finally, the multivariate k-nearest neighbors. And so this is essentially, it's how close to the next closest point is it? And it's trying to find the points that are so far that their next closest points are some multitude of distances from the average distance between points. So this does a really good job if you have lots of points scattered in a distribution and then some that are just really far out. And so it picks out those points that are clumps of extreme points. All right. So that is extreme values. Now I have completely forgotten what our schedule was, so I'm going to poke my head over here and look at it. It is 16. Okay, so we have 20 minutes. I think I'm actually crazily on time. Any questions on extreme values? Some of that seemed pretty useful? Okay. Now just in the brief bit, I want to talk about missing values. Oh yeah.
You said you were going to record this.
This is all recorded. Yep.
Will then be a webinar that we can watch in YouTube.
Yeah, so what I'll actually do is I'm going to send it on to Alex and Martin, and they're going to pass it along to just you.
Okay.
Yeah. I will say that some of this, have some of you taken the News or Welcome kit? A few, maybe. We're hopefully going to build a data prep kit as well. So a series of these that are guided exercises with some things you can do. So some of this will be that too. But
So will the data sets also be part of this?
yes. Oh, and I should say, any data that you've seen, with the exception of, no, actually all the data you've seen are built into JUMP under sample data. So in case you've never done it and you just feel like playing with some data, go to sample data and it's all listed by type of field, area of industry, that kind of thing. And so if you're trying to, play around with control charts, you can launch a data set. It almost always has a script, so you can look at, what types of things you can do with the data. Yeah, so again, help sample data. And yes, I'll include the journal for sure as well. All right, missing values. So this is kind of a separate issue when your table, and you've seen them throughout today, you have these dots when you have numeric data that's missing, or when you have categorical data missing, it'll simply be a blank cell. Now, these data aren't terribly big. There's 32 columns and 239 rows. It's big enough where if I asked you what was the pattern of missingness, that is what columns tend to be missing and in what clumps or what combinations, it's big enough where it's going to be hard to spot what columns are not available. So there's a couple tools I want to point out. And missing data pattern is one that it's been around for a while, and I think it doesn't get used as much as it should because it lives under the table menu instead of under the screening menu. And so let me show you this. So tables, missing value pattern, or missing data pattern. The way this works is you first provide a series of columns you want to explore the missingness across. And so I'll choose just 4 columns at the start, then we can expand this. I'll click them to the Add Column section. and I'll click OK. Now, interestingly, what JUMP gives you is a table as an output here. And in this case, it gave us a table that's linked in the sense that if I click through, the rows in this table are linked to rows in the original table. What this has given us is the 6 types of data we have with respect to missingness in the full table. So 216 rows in that full table out of 239 have 0 missing data in those columns. So the pattern is complete, 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 complete. No missing, no missing, no missing, no missing. The 0000 refer to population, crude death 1000, and infant mortality. So this is a reflection of the order of the columns in the table that I gave it. Another way to see that is if I look across, these 216 rows do not have missing for population, do not have missing for crude death, do not have missing for crude birth, and do not have missing for infant mortality. 5 of the rows are 0001. They only are missing for infant mortality, and that selects them when I click on it. 1 row is missing for both crude death and infant mortality, 1 for crude death, crude birth, 5 for, looks like the last 3, and then 11 have missing for all. Now, if I really needed data from the whole data set, that is a pretty alarming thing. 11 out of, maybe that's not too bad, but are missing for all those values. So I might want to then do a data view to see if I have data on anything from those countries. And I totally don't. So those are just like a waste in my table. I may want to, like if these were processes, I may want to actually explore those machines. Right? There's something about them not giving me data. So missing data pattern does a great job. It finds the patterns of missingness. It comes with a couple scripts. So if I look at a tree map, are you familiar with tree maps or have seen them? Basically, size here reflects the area of the table. So we've just count is the frequency here. So most of our data is complete. Some are all missing. And then there's a smattering of other things. And then a cell plot's kind of neat too. This is now looking across the columns. What is the missingness? So a lot of completes, some that are missing just 1 column. Sorry, I should say these 6 rows of the cell plot are the 6 types of missingness. And the heat mapping is whether it's missing or not. So complete data is red, incomplete data is blue. So there's some that are all missing, some that are perfect, and then some patterns in between. Now, one thing you'll find with missing data pattern is that when you throw your whole data table at it, you'll find that there's plenty of ways things could be missing. So if let me make this a little smaller so I can grab the bottom, add these to my columns list. So there's 44 different ways that these 32 columns have missing data. And if I sort, this is usually my way, I'll just sort descending. Oh, it's a lock table, so I will not sort descending. Oh, right, because it's increasing levels of missingness it wants to ensure. So I only have 88 rows of complete data, right? But if I needed to find the complete data, this is literally the fastest way to find it in your table. And if I go to the bottom, I actually have 11 rows of all missing. I already identified those. And then everything in between. And so the tree map is nice because you can find the next biggest thing that's missing. So one where, let me actually select it here, that's everything except for, what do I have missing? If I scroll across, I have average years of education is missing. This is actually a place for the row editor. If I double click, very easy to find that row edit. It's a missing data pattern. And then the cell plot sometimes can shine light on what things co-occur in missingness. Right? In this particular example, there's nothing that pops out, but there's some where essentially a variable that's derived from another variable, it's obviously missing together always. And I have seen people who actually use missingness as a type of analysis. So you could actually throw this into something like a sparse principal components analysis. So look at missingness as or I guess it would be multiple correspondence, what things tend to co-occur in terms of missing. All right, so that's missing data pattern. Now that's not going to do anything for imputation, but I just want you to see that explore missing values, another option under screening, does give you the ability to fill in those blanks, although, again, we can take a place on whether that's a good idea or not. So under screening, explore missing values. Again, we pass along the actual columns we care about. And we have a number of options here. We can just do the missing value report, which is very similar to what we had before. Missing value clustering does a sense of the thing that I was describing, finding what columns co-occur in their missingness. There's a lot to unpack with that one. Missing value snapshot, I think, is really neat. So imagine we're looking at our table, and instead of looking at the table with the numbers, we're just looking at whether data are missing or not. So rows go down. So you can see somewhere in the table, the first bit, there's some missing, then a big blank section of complete data, and then some missing. What's really valuable here is when you have sequentially collected data, you can start to notice a machine failing, because suddenly now there'll be a big block of missingness, and then maybe it'll start being filled in again. So missing value snapshot is really quick, especially for large data tables. And then you have the imputation options. So again, I don't want to take a stance on this here because I think there are varying views on it. Imputation essentially says fit a model and then predict the missing values based on the model you have. Now that doesn't add data from a pure information theory standpoint. You can't make up data and have it be meaningful. What it does do at times is allow those rows to be useful for an analysis. So for instance, we have only 32 rows in this data set. Maybe a particular country is missing just one value, but it has all the rest of the data, and you're using all 32 columns in an analysis. If you impute that one value, that country is now usable in that analysis. Whereas if you didn't, you'd have to throw out all the data. So there are times where that imputation maybe is defensible, especially when you really understand the process that goes into that particular value. But normally imputation is, it depends on the field. It's something that it could be very casually done or something that's frowned upon. So find out what your field says. But whatever the case, JUMP will do it in really great ways. And so multivariate normal fits, essentially, it's like linear relations between the data and imputes based on that. SVD, multivariate singular value decomposition, when you have really wide data sets and you need to impute. Normal imputation could get very slow. So SVD is a numerical algorithm to make that faster. And then automated just figures it out for you. It just guesses. So a lot of options there if you really need to work with data that have a lot of missingness. But I think the missing value snapshot, without doing anything modeling, just gives you a great way of looking at your process and seeing if something is going wrong. So I highly recommend that. And I always like to stretch it out because that gives you a sense of where in the table things are missing. All right. These are pretty cool data, by the way. They are built into JUMP, and hopefully you can make maps in JUMP in Graph Builder. So if you ever were curious, you can like play around with the map and look at, mortality. Well, that's pretty grim. Let's do years of compulsory education. There we go. That's kind of cool. So another way you can have something cool in your desktop with your spinning plot. Yeah. Yeah. While we're here, though, it's not really a data preparation thing, but I showed you the local data filter, which is an incredibly powerful way of looking at pieces of your data. A potentially equally useful thing is the column switcher. So you saw me, I dragged a different column in to color by. What if I wanted to look through all my columns in this graph? Under the red triangle, under redo, this is everywhere in JUMP, is the column switcher. And the column switcher says, you have a column that's currently used in this analysis or this graph. What do you want to switch out for? So I'm going to switch out years of compulsory education for pretty much anything else that's numeric in the data table. Actually, I'll just take everything in the data table. That's fine. And what this builds for me is a little switcher where I can click through the columns. Now this ends up being really powerful because imagine you have, I don't know, an analysis. You're fitting a linear model, let's say, predicting, I don't know, overall life expectancy at birth as a function of a bunch of things, right? And you want to fit this entire model over and over with different responses. So I can say, well, give me a column switcher, overall life expectancy. I want to fit the same linear model for these 6 variables. And so now you can toggle through the different outcomes and fit those different models. So it gives you a way to switch between or switch in and out a variable in an analysis or a graph. So not exactly a data preparation thing, but something that's very, very valuable when you're building graphics to share with people or to communicate your findings. So again, red triangle, redo, which is where you find the options to repeat an analysis, and that's where you find the column switcher. Or you should have them in your menu bar. Usually you have icon and text, and it looks like that one. It shows the column highlighted, whereas the data filter shows the row highlighted. All right, so that was a lot of stuff. It is 4:20. This is perhaps the first time I've finished ahead of schedule on something. So
You're in Switzerland.
that's maybe what it is. So some questions. Anything that's stuck out to you, or things you'd want to see more of, or questions you have? I think we have specifically, I'm trying to think what time we had set up for questions at, I guess at 45 after. So I don't know, Alex may talk about some things, or we can take 10 minutes now if there's anything that popped up. Yeah.
Quick question. I know you showed it like in the webinar.
Uh-huh.
For example, you have a big data set and you only want to analyze a few columns and you don't
Yeah.
actually want to delete anything.
Yeah.
How do you again? I can do it on the rows, like right-click data set, but I'm not able to right-click.
Yeah. No, I think, oops, jump 16. Don't show you that. There we go. Let me open it in jump 15. So there's a couple things you can do. You're right. So if you select some rows and then do, yeah, the data view here will bring out all columns. And if you want just a few, so let's say you want just these 4 columns plus those rows, I would use table subset. And subset, unlike data view, you can actually specifically say just those columns and just those rows, and then you get this nice and compact little one. Sometimes really valuable when you have, I have some that have like 200,000 columns, and it just gets mind-numbing to look at all of them. What I'll say is if you do that subset, you have the option of having it linked or not linked. So link to original table. If you link it, that literally means that those rows now are the same rows and columns. So that does like data view, where if you change something here, it'll change something in the original table. If you don't link it, it's a separate table. It operates separately, and you can save it separately. Yeah, great question. Mm-hmm. Yeah.
This column switcher, when you go to this, maybe, can you, because I tend to get all columns and go through it, and then I look at the data really, if it really is useful or not. Can I then, when I see, oh, it's not useful, and someone delete it out, that later on I can.
That's a really good question.
A subset of columns.
Right. So let's say I had one and another. This is a good data set for this. So I column switch out, let's say my Y column with, all of those. Right. So you're going through. You're saying useless. Oh, interesting. Useless. Yeah. It would be nice if you can just remove it here.
Just delete button.
Yeah. Oh, did it work? Okay. That might be new. That's I just like to try things. That's impressive. I did not think that was going to work, but all right.
Somebody obviously has the same problem.
Yeah. That's pretty impressive. Yeah, that it does that. But that's great. So yeah, you can go through and say, it's trash. Yeah, then. One thing that's nice, and yeah, once you have that list, you can go back and investigate them further. Yeah. If you save the script now, it should have, yes, it has your list of them. One thing that's kind of neat, let's see if this works. I can select them in that script, and I think if I click in this Y, it doesn't work. You can, if you select in certain places, paste in a list of columns. I thought that might have worked, but they didn't get that clever. Let's try one more time. No, that's too bad. But yes, the delete. We had one win. Yeah. Any other questions? Well, we'll have time after Alex talks to you a bit, so you can percolate on that. I'm going to pause my recording.